Hey guys, what's going on there? In this video, I'm going to be doing something very phenomenal. We're going to be talking about OpenCV for computer vision. Now, there are quite a lot of things we're going to be doing in this video. I'm going to be taking you from how to kind of get started with OpenCV, some of the syntax, not only like some syntax actually, more of the documentation for OpenCV and some of the useful methods that you could use in doing something very astonishing in your maybe deep learning or machine learning project. Now, the truth is that one of the reasons why we use OpenCV is that OpenCV was built in 1999 by Intel, and it's something you can actually use in writing images, you could use it to write in images, saving images into a disk. You could use it to, maybe kind of put some text on an image. You could use it to launch your camera. Basically, when it comes to object detection, edge detection, image recognition and pre-processing, OpenCV is a very fundamental library that is used, particularly in Python, for a lot of all of this. So I've kind of made some notes in the in as markdown for this particular tutorial, and I believe some of them are actually going to be important because the aim here is to make sure that everybody understands how to get started with OpenCV, and of course, performing some of the nitty-gritty requirements, particularly for this course. So in the next, couple of minutes or hours, we are going to be looking at how we can shape our understanding of OpenCV. Now, I'm not going to waste so much time. Now, if you kind of look at this uh, here, this is my VS Code. I've kind of done some stuff, before now. And this is kind of, some of the dependencies that you need to import. And then if I kind of go down, okay, so I could just start by taking so many of these down and just to get everything started and just to make it easy. Now, I've kind of made some documentations from here, how to read an image. I'm going to show you how to write an image, how to perform flipping, how to resize, modifying pixels, how to launch the camera. And each time before I kind of engage in any practice, I'm just going to give you kind of uh, a warm refresh now of what I'm doing so that that's really going to make some sense for you. I think somehow uh, we might have, made our way with that. And okay, so what we're gonna do right now is I'm just gonna delete this, and that's it. So we're gonna now to get started now. Uh, we're gonna call this open. Maybe we could say opens. Then I'm gonna underscore cv dot. I think that's dot OpenCV dot interactive Python notebook. Okay. All right. So this is where we're going to be performing our practicals and all of that. So it's going to be quite a very engaging. I'm going to be doing a lot of things, and just to make sure you're very much comfortable working with OpenCV. Okay. All right. So now without wasting too much time, the first thing I'm going to do, I'm just kind of I'm going to start by importing some of the necessary dependencies. And I'm just going to call this okay, OpenCV tutorials. Okay. And for maybe it could be for machine learning and deep learning, right? So those are actually that. And then now the first one we're going to start with right now is just to keep this simple, we're going to start with how to read an image. And before we do that, we'll have to set our kernel. So I'm going to click on this kernel to select that's the environment where I'm going to be working on. Now, I'm just going to make something very clear in this video is that if you're watching this video, I kind of feel like you should be comfortable coding in Python because Python is a very good requirement for this particular exercise, right? So you need to be comfortable coding with Python, right? So that's some of the things that I'm just gonna say is gonna really make a lot of sense for you. So the first thing I'm going to do now is I'm going to say reading, or maybe I'm going to kind of say maybe here it's going to be reading an image. Okay, so yeah. Now, what's actually the first thing to do? The first thing we're going to do now is to import all the necessary dependencies as the libraries that we are going to be using. And I'm going to import OS because I'm going to create a folder. And I'm going to import CV2. That's the computer vision, right? So that's what it is. So, but you could try to have this as an alias as CV. That still works, but I'm just going to leave it as CV2. I'm going to import NumPy as MP because we're going to be generating some data set. I'm going to import matplotlib.pyplot as PLT because we're going to be performing some sort of visualization. And of course, we could still use OpenCV, but then it's just to make us uh, comfortable with several methods that are applicable. Now, this is actually some of what we will need for this particular course. Excuse me. I think those are actually definitely going to be important. So yeah. Now I'm going to run that just to be sure that are now saved on my kernel. And the first thing we're going to be doing now is reading an image, all right? So basically I'm just going to put some comments here. I'm say this is for handling files. And then I'm going to say this is for computer vision and image, maybe whatever I could call image processing and all of that. And this is for computation. And so this is for computation and mathematical operations, okay? And then this is for visualization, okay? So this is actually what we use some of these libraries to perform visualization. All right, so that's actually going to be that. Now, I could just have this markdown closer here, so probably let's say importing dependencies. And then here, of course, I could just put another markdown. I think that's going to work well. Let me see what works. Okay. Now, I'm going to say something right now. Now, for you to read an image, now we could just go to the internet now. Let's say, for example, I go to the internet and I search for face of a happy girl, for example. Now, this is an image, right? All of these are actually images. And then probably I try to download maybe one of these images. Let me just kind of find one that I like. Okay, let's go for this. I think I like this. And then I do like all actually. So I'm going to save this in my desktop and I'm going to save it as maybe happy girl. Yes, happy girl. Happy girl. I think that's fine. Happy girl. So I would save that. Now I save that as JPEG. No issues with that. And what we are kind of talking about right now is how do we read that image? Okay, now there are two things I'm going to be doing in this particular tutorial. I'm going to be showing you how we can generate an image using the NumPy library, and then I'm also going to show you how we can read this image. Now, usually the first thing we might want to do now is to create a path, right, where we can store images. Let's say, for example, I want to download images of happy girls, then another image of a sad girl. Let's go back to the internet now, okay? Now, I could just come back here now. I'm going to say image of a sad girl. Then I'm just going to click on images. And then these are a lot of images of sad girls. So I'm going to check. I think I like this. So I'm going to right click and I'm going to save this as sad girl. Okay. Still on my desktop, so I'm just going to hit enter and that's fine. Now, if you kind of look at what I did now, right? I have an image of sad girl and an image of a happy girl. Now, but then these images have not, I could want to access them here. Of course, I'll have to go to uh start looking for it in my desktop and all of that. But then first what we might do now, good practice is to create a folder. Okay, so we're gonna create a folder for that. So what we're gonna do is say, what we're gonna say now is this. Now folder. It's going to be equal to res.path.join, and then we're going to call it uh, happy data set. Okay. And then, of course, we might want to pass kind of a placeholder that requires os.make directory, and then we're going to pass in folder, and then we're going to pass in exist equals to true, and that's going to create a folder. So that creates the happy folder data set. And then we'll kind of do the same thing. Now I'm going to say new folder, turn equals to os.path.join, and then we're going to say sad data set, and then we're going to see os.make directory, os.make dice, and then I'm going to pass in new folder, and then of course exists equals to true. Okay, so each time we run that, we're definitely going to get that. Okay, cool. Now, what we are going to do now is to now save that image that we have in our desktop inside of here. Now, we could do several things right now. I could want to kind of track that image, but what I'm going to do now is I'm going to come here, I'm going to drag, this is the happy, I'm going to drag it into this folder, and then when I click on that, you see that it's now inside of that. And then I'm going to pick the sad girl, drag it into this folder. Okay. So this kind of a manual approach to that. So if I kind of click on this image, you see that that's a sad girl. If I kind of click on this image, I see that's a happy girl. Now we're going to return back here. Now, what we just did now is we have now created that image, right? So how do we now we've kind of dragged that image to that part rather. Now, how do we now read the image? Now, if we want to read that image, I could say happy girl. I'm going to say happy girl uh, image is going to be equal to cv dot, now this is cv2 now dot im read, right? So we are reading the image now. And then we're going to pass in, what we're going to pass in now is the folder. So we're going to see happy, that's going to be a happy data set. Okay. Just to be sure that's how we spelled it. Let me just be sure. Okay, that's happy data set slash, then we're going to have happy girl and then dot JPEG. Okay. So kind of read that image. And then even if we do cv2.im show, and then we're passing happy girl image. Let's see what's actually displays. Okay, kind of loading. What's the saying? Okay, all right. So what we're going to do now is, so since we've read this now, we could use matplotlib to read that, right? We'll say plot dot image show, and maybe first I'm going to say plot dot figure, and I'm going to say fixed size of 5 and 6, and then I'm going to pass in happy girl image, and when plot dot axis. I don't want the axis to be there. I'm going to say off, and then the plot dot show. Now, what did you notice here now? Let me show you something now. You can actually see this image, right? It's kind of blue, and that's kind of BGR. So that tells us that OpenCV returns, it loads its images in BGR and not RGB. So BGR, right? So I'm going to say OpenCV loads its images in BGR, right? That's going to be rather than RGB. RGB. Now that's that. Okay, so I'm going to be showing you how we can load this in RGB. Still possible we could do RGB image happy. I just want something you can remember. Happy image is going to be equals to cv2 dot imread, and then we're going to say we're going to pass in happy girl image, comma cv2 dot imread, then we're going to say color RGB. So we're going to plot dot I am show, let's kind of show that RGB, happy image, and plot dot axis of, okay, plot dot show. And then what's the issue? It says overload resolution failed. Okay, okay. Read happy image, cv2 dot this, and okay. So we want to kind of change that, it's kind of expected it to be a string. Now, what we can do now is let's kind of print RGB up image the shape. Let's see what happens. Okay, so that means um this is actually supposed to be an image. So we're gonna print, let's say, RGB happy image, and then I think let's kind of see what. Okay, so we're just gonna run all ourselves to be sure that that's it. Okay, now what I want to do now is I just want to convert the colors, right? And so what we can do now is I'm going to say, since we are good now with reading the image, we could say okay. Now let me get the part. Okay, so that's what it's supposed to be. That was, and that works. Okay, so I'm say plot dot show, and then we're passing, uh, RGB happy image, and then the plot dot axis of plot dot show, and then you see that we get a real image of the lady. Okay. All right, so that's actually going to be that. Now, I just basically what I just showed us now is how we can read images. There are lots of ways. I'm definitely going to create one with synthetic data set and then how we can manipulate, resize this image, assess sizes, and of course, do a lot of things. Now, I could show you maybe plot, I could print, maybe we want to access the properties of this. Maybe you could do rgb.image.shape, and then you're going to see that this is 280 by 200 by 390. That this is a three-dimensional array. So if you can say RGB image, if you can say print RGB, maybe see dimension of image, and then you kind of see uh, RGB happy image dot n dimensional, and then it's going to show that it's a three-dimensional array. Okay, because if we kind of check, I'm just going to kind of do that on a new line, and then maybe if I say print type of happy your image, that's going to tell me that's a numpy array. So this is now one of the things I want you to understand now is that how the computers do view images in as pixels. So this what you're seeing here is not this is not how a computer is viewing this. It's not like seeing a girl. What the computer is seeing is kind of seeing some tiny boxes that we call pixels. Okay. So there are some kind of tiny boxes that we call what pixels. That's what the computer is saying. So we call them pixels. Okay. So these are just kind of some tiny boxes that the computer sees. And then if you kind of remember when we talked about NumPy array, when we talked about tensors, handling images and all of that, one of the things you need to understand there is that there are most of the images that are passed through the neural network and all of that, right, kind of stems from maybe let's say NumPy arrays that are three-dimensional. So some of these pixels, now let's say I want to create an image and I'm going to say this is np.random.randint, and then I pass in the numbers from 0 to 255, and then it's going to have 300 rows, that's the height, 400 columns, and 3 color channel. And then the D type is np.uint8. And then I kind of print the image.size. Now you're going to see that this is, okay, size is going to multiply it's going to multiply all of this, right? And then it gives you that. So if you're going to check image the shape, it's going to give you this 300 by 400 by 3 color channels. So that is more of how we check the shape of an image array, because this is definitely an array. Okay, click on print type of image, and then it's going to give you an array, the class of an array. So, not so much confusion there. I've kind of showed us, I've kind of gotten a data set, or what I'm going to refer to as an image online, and then we've kind of displayed it. Now, what are other things we need to understand whenever we are reading an image? Okay, so we could want to talk about grayscale, right? How to display an image in grayscale. So what's grayscale? Grayscale is a two-dimensional array that has just one pixel values with numbers between 0 and maybe 255 and all of that. So let's say, for example, you have gray, gray image, right? And then want to display this image as a gray image. We're going to say cv2.imread. Let's kind of read it as a gray image. Want to read this image as a gray image. Let me just say read as grayscale or image, however you want to put that. So we're going to say, I'm going to pass the file path now, right? So we're going to say happy data set slash happy girl, right? Dot JPEG, okay? And then we'll say cv2 dot imread and then underscore grayscale, okay? And then we're gonna plot dot imshow and then we'll pass in gray image and then we'll say plot dot axis. Okay, now let me kind of run this so you see why I always turn off the axis whenever I do this. Now you see that we're kind of having this 0 to 1, 0, 50, 100, all these kind of numbers that are here. So unless I cannot turn it off in plot dot axis, I could use false. That's still definitely going to work. It's going to remove that. And then if I want to kind of maybe handle the size, I could say plot dot figure, and then I'm going to say fig size of maybe 6 and 7. That's 6 inches. That's the height, and then this wise, you're going to see it's going to be kind of wider. And yeah, I almost like slightly the default. But let's kind of reduce this to 3 and 7 and see what happens. Okay, so you see 3, height, and then so I'm just kind of trying to compress that. So I think I'm just going to stay with the default. So this is kind of how we load a grayscale, right? So this is not really what we want, but that is also part of what we do. Now there are also other inbuilt method that we have cv2 dot excuse me. We could do normal image. Remember that by default, OpenCV returns it as BGR, right? Blue, green R. That's because if we do the normal image of, let's see, cv2.imread, and then we'll pass in that, let's do for sad girl this time. So we see maybe sad dataset slash sad that's sad girl dot jpeg, and then we'll do cv2 dot imread, and then we'll say maybe normal color, right? Or just say color. I think that is color, and then I would say plot dot. I think we'll do cv2. Let's try cv2 dot im show of number. Okay. Let's just plot dot. I am sure that's using the matplotlib library. It's a normal image, okay? And then you see that that's on a good scale. But let's kind of look at what the real picture looks like. So you can see that, right? So if you look at this now, you see that this is BGR. It kind of converts it to BGR instead of RGB. Now, I am just kind of making this whole mastery possible, by trying several things. We just keep trying how to do this, how to do that, and then, just so we can actually know that there is a lot of possibilities in how we get some of these things done. And I think that could be that about reading an image. Maybe the next thing we could do now is to create our own synthetic data set and then see how we can, of course, read the image, right? Now, let's say, for example, now I'm going to create a random image. Then I'm going to say np.random.randint. And then I pass in, let's say, for example, it's going to start from 0 to 255. And then it's going to be 200 rows, and then it's going to be 300 rows. Or maybe it could be 450. It could be maybe 500. And then it has three color channels. And then it's going to be dtype mp.uint8. Okay. Now this is the image, right? Because if you kind of print, this is a numpy array. If you print types of random image, is going to return a numpy array. Now, but what we can do now is now we are moving into how to write, okay? Write and read, okay? We're moving into how to write and read an image. That's how to save an image to a particular to the disk for it to read. Now, what we are going to do now is that with this image now that we have here now, we could just say cv2 dot we could say cv2 dot and now this time around I want to say I am right? And then this I am right is image right. So we're going to call this image photo dot png. Now, whatever extension we use here, it's definitely up to you. That's how it's going to. Could set to JPEG. That's going to work. You say GPG, or you could say maybe any other one that you find, very, very interesting. Maybe BMX, be whatever thing, and all of that. So in this case, I might say PNG because we do still save photos as PNG. And then this is now what we call this first argument here is going to be what the format of which this image is going to be saved. And that's kind of a placeholder for the title of the image. And then I'm going to say random image, okay? And now I've kind of written that. And also the next thing that will happen now is that you see that that image is created. So I could just hover that and you see that this is just an image, right? And what you need to understand now is that if I kind of click back here, so I could set to plot.show and that's plot.image show. And now I'm going to pass in that random image because each time you call plot.show, matplotlib is expecting a numpy array, right? And that is where this is. And of course, I'm going to plot.axis, I'm going to turn it off. And let's kind of see what happens. And then you see, that's it. It gives you the image. So that is going to be that. Now, there are several ways we write an image. We could read, write, and but actually for this session, this is some of what we need to understand. Now, the next part we're going to be going into now is we're going to be looking at image properties, right? Image properties. I'm going to call image properties. So I kind of showed you what some of this means now. Now, there are several pictures on the internet right now. And like I said, I did tell you that computers visualize images as pixels. Okay? They visualize images as what? Pixels. So that means pixels are some kind of tiny blocks, right? Now, let's take, for example, now this image now that we have here now, right? This photo. Let me just print random image and see what we're going to see. Now, you see that it gives me a NumPy three-dimensional array, right? Which I've kind of said, but I'm just going to kind of give you a quick crash course on what a NumPy is. Now, what NumPy is now, NumPy, NumPy is a library. NumPy is a library that is used for mathematical computation, okay? Now, what other things NumPy contains what we call arrays. That's what we call what? Arrays. And that's what NumPy arrays is. Now, I could just show you what a normal NumPy array is. Maybe probably simple, let me call this simple array. And I'm going to see this is going to be equals np.array. And then it's going to take in maybe a list, a pass a list inside. I mean, probably I'm going to call it 434 and this, right? Let me just kind of, so we're just going to print simple array and it's going to print that. Now, based on simple array, now let's kind of print now type of simple array, right? So we want to know what is the data type. So I'm going to just kind of put a comma here. I'm going to see here, what is the data type of this array. So I'm just going to put down an arrow, and now I'm going to kind of print uh, what is the dimension of this array. That's the dimension. So we'll see simple array dot n dimension, and then we're going to print what is the size of this array. And then I'm going to now have, okay, what's the issue here? There is no comma. And then I'm going to see what's the size. I'm going to say simple array dot size. I'm going to also print what is the, now I'm going to print what is the shape of this array, right? So I'm going to kind of have simple array dot shape. And I'm going to print all of this to see what it kind of gives us. And then you see that based on this particular array here, the dimension, first of all, the data type is a numpy array. And then it has a one dimension, so that's one. Okay, so if you kind of look up my linear algebra class, where I've kind of explained some stuff about dimension, vectors, and all of that. So just think about this as a vector, right? Kind of a simple vector. Now, in terms of the size of this array, it contains two numbers, that's 1, 2. And then in terms of the shape, it is just 2, right? 2 by nothing. So this is just uh, this is just kind of an array that contains two numbers, okay? And it just has two columns. Let me just put it that way. Let's just say maybe I add like maybe 50, 67 here and see. You see, just kind of three, right? Nothing. Now that is really very helpful for us. Now I'm just going to copy all of this now. Okay. Simply there's really no time to start duplicating code. Or maybe let me just kind of change this code, this now. Maybe I add another dimension, add another block here, and add another block here, and then run it. What will happen? So see that I've added another dimension here, and it's now having what? 1 by 3, right? Still, but this time around, size is still 3. It still didn't change. And then, but then, literally, what changed now is the dimension, right? It's now 2 instead of 1. It's now 2 instead of 1. Now, let's say I now kind of want to add another number. Maybe I'm going to say, uh, maybe I say, probably, let me just kind of have that. And then, maybe, of course, 90, 56, this. And then I kind of run that. You see that I now have what's the size of this array is kind of 6. Just important for us to understand this, right? And of course, I'm just gonna try to get that shit down. Okay, all right, cool. Now you're going to see here that for simple array, the n dimension now is that what? Is now 2. It's still 2, right? Because we have just kind of look at the two block brackets before. You have some of what's actually inside of it. And but essentially what you need to understand here is that the shape has kind of changed. Now you're gonna see that we have 2 rows and three columns. That's 2 rows, 1 row, 1 row. That's 2. And then 3 columns, 1, 2, 3. Okay? So that's just let me just show you what I'm talking about now, right? Maybe I'm just gonna come here. And of course, we're just gonna let this load. I think I don't want this, just gonna close this. And now this is what we're kind of talking about. Now let's say we have a table like this, right? If I could draw that well. Oh, sorry. My hand is kind of on top of my table. Let me kind of carry you. Okay. Oh, sorry for my bad drawing. And okay. Now, what this is actually saying now, this is our rows. Now, going down like this is our rows. And then going this way is our columns. All right. So in that case now, we have one row and then second row. We don't have one, two, three. We only have three, right? We don't actually have this there. But then if we, sorry, but if we kind of add another one there, maybe if we come in and add, uh, let's say we add that for you and we don't add here, it's going to throw up an error because there's a mismatch. Now let's check them and confirm. So you see, it throws up an error because it lacks the right shape. So meaning that we have to kind of add something here and add one, and that works. So you see that the shape now is 2 by 4. So that's why we have 2 by 4, and that's just basically what it is. So here, 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 and then here, 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 here. Okay. Now, that is what that is going to be. This is going to be a very fast crash course, and just to kind of get you started. So this is what our shape and sizes looks like. Now, the same thing also applies when it comes to our image, whenever we're visualizing an image. Now, look at this image of this sad girl now, for example, and let me just kind of go back there, and then we'll say that image sad, let's say sad girl image is equals to, like, first of all, we have to read it now, right? We have to read the file because we cannot just type the directory. Let's say we type the directory, what we try to do then, let's say sad dataset slash, maybe sad girl, maybe sad girl dot JPEG. And then we try to do it this way. Of course, this will work because we kind of assigned it here. But if we try to print uh sad girl image, it's not going to work because this is if we try to maybe kind of assess the shape and all of that, it's not going to work because this is just a string. This is just a string. It will print a string. But if we try to plot it now, it's going to tell us that we are passing a string. Let's see. If you say plot.im show, and then you kind of just pass sad girl image, it's not going to work because this is a string. This is a what? A string. All right, so that's it. It tells that image data cannot be converted to a float because we need to work with numbers. So it needs some kind of numpy array. So that's why we're going to quickly delete this, and immediately delete it, and then we will delete it, and then we're going to announce, okay, so what is sad girl image? We're going to wrap this with cv2.imread. Please read this then, and then of course, how do we want this image? How do we want it? Do we want it as a grayscale? So let's say we want it as cv2.imread, and then we'll now say maybe grayscale, right? And then now watch what's going to happen when we check the image properties now, because right now we are getting into image properties. Okay, that's image properties. That's where we are. And then what I'm going to do now is, if I kind of say print sad girl image dot shape, now it's going to give me a two-dimensional array, right? It's going to give me two-dimensional array, and then maybe let me just kind of put some comments out of that. And then maybe I could see here I'm going to say, I think it's fine if we just call it uh, sad girl gray image, okay? Gray image. So it is easier for us to kind of remember that. So I'm just going to put that sad girl gray image dot shape, okay? And then I'm going to say shape of sad girl gray image. And then I'm just going to kind of copy this. I'm just going to copy this. I'm going to paste it again. I'm going to, this time I'm not shape. I'm going to say size. And then it's going to be dot size. That's the endpoint. And then I'm going to print. I'm going to also print. This is not sad this time. But now maybe we could say the dimension. That's the dimension of sad girl gray image. And the image is going to be sad girl as usual. Sad girl, no, so gray image dot end dimension, right? So I'm gonna print. I think I could just copy this, maybe being very lazy too. And I'm gonna sad girl. Now this time around is not size. What else can we actually look at? What other properties? We could say shape. We could check the shape. Maybe we could check. We're just gonna screw up to see what we're able to do, and size, shape, and dimensional, and the type. Of course, the type is an array. So we could say type. Okay. So these are actually properties. So here now, instead of, I could do dot d type. Let's see what happens. Now, now I'm going to explain this part now, right? I'm just going to put this thing here. Now, you would remember that when I was creating an image, right? I use what we call the uint. Now I'm going to explain this again. Now, what the uint stands for now? The uint stands for unsigned integer, right? Byte 8. That's what it stands for, right? Unassigned integer byte 8. So it means that it kind of gives no negative numbers, no negative numbers, and also aside from the fact that it doesn't give negative numbers, it does not, it is just kind of, it's most of those images, right? Unsigned images are between it does stay in the range of 0 to 255. Now, this is just only for these images. Now, that's for the images. That's for the images now, right? Mostly whenever we are passing for, maybe we are trying to create synthetic data or any kind of stuff, right? But just basically what you just need to understand that is what unsigned what numbers. That's the key thing to understand, right? So it's not even about non-negative numbers, but actually that's it. These are key information that you need to highlight. So now now that we have actually had this insight now for the gray image, now let's kind of see, I mean, kind of copy this and then let's do for, maybe we're gonna say this is now for the normal three color channel, okay? Because you know that we have three color channels in an image, right? Let me just kind of copy this and paste it here. So what I'm going to say now is I'm going to say, no, this time let's use sad girl again. Sad girl RGB or sad girl color image. So the color image now is by default usually returns BGR, right? That's what we say, BGR. cv2.imread, and then we'll pass in the file path, right? So I'm just kind of going to copy this and uh, and of course, then I'm going to pass in CV2 dot imread, and then it's going to have an underscore of maybe BGR. Okay, so plot dot. Of course, we could want to show that, but that's all. I didn't want to access the size. So what we're going to do now is we're going to print the shape of sad girl column image, right? We're going to say sad girl. That's going to be sad girl color image dot shape. And then I'm just going to kind of, so this is going to be, and then I'm going to say type, so that's the type. Oh, what's the issue? What's the issue? Okay, we forgot to put an underscore here. I think that should work now. Okay, so now, like I said, so you see that shape of girl color image is you see that it has a three-dimensional, and compared to this other one, which is two, and this other one is kind of three. Now I'm going to talk about how we can access uh you know how we can access and modify some kind of pixels next. But before then, I just want to kind of show you something. Now, since we are now conversant with this now, we could have an image now. Let's say for the happy girl image now, let's say uh, folder, or we'll say path is equals to, this time around, we're going to be using paths. So we're not going to have to be writing so much of the code. So happy girl slash, and then happy girl, right? Dot JPEG. Now that's actually the part that we are using, right? So what the implication of what this means now is that since this is the part that we are using, since this is the part, right? And we could always do maybe to check the size of this image now. We say image is equals to cv2 dot imread. Okay, normally then we'll now pass in the path, and which is going to work, of course, because when we say plot dot imshow, and then we'll pass in image. Of course, it has to work, and it's going to give us the image in BGR, right? And then probably let's decide to plot dot axis, then kind of turn it off. And that kind of removes it. Now, one of what I want you to understand right now is that uh, this image now, right? We want to know how to access some of the pixels here, right? Now, if I could just watch, if I kind of print image, right? It's going to give me a numpy array, right? So what do I mean by a numpy array? This is just an image are just numbers. So let me just go back to my drawing board and kind of show you something, right? Now this is how the computer sees an image. This is a box. 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 Another box. Another box. Another one. Another one. Now, all of this now, sorry, pardon my drawing. So all of these now are kind of, oh, sorry, I kind of made a mistake there. So all of these are kind of, let me put it this way. I'm going to say these are boxes, right? These are like boxes that that are used. That this is how a computer views an image in a moment, right? It doesn't really see it the way we think it is. So when you kind of zoom into an image, let me show you this image now. If you kind of zoom into this image now that I created now, right? Let's see if we can just kind of zoom in. Okay, maybe probably I could just save that to my desktop. Let me just kind of snipe that. So snipe, and it's gonna let me snipe that. So the next thing I'm gonna do now is we're going to save. We're going to just save this on our desktop uh computer image, okay? And that's a PNG file. Now let's just kind of open that. Good. Now let me zoom in. Let's zoom in. Now you see that when we come inside of here now, this image here, what what the computer is seeing are just boxes, right? Box of numbers. And each of those box contains what we call, uh, in this particular case now, it contains three numbers, right? Which are numbers that has three color channels. So, so that is how the computer do view that, right? Basically, it does contain what? Numbers with what? Three color with three colors. That's three numbers, right? That's numbers that has, I would say an array that contains numbers with three corrections. That maybe that might be fine for you. So I'm just kind of trying to paint that picture for you now. So what it means is that there are we could access those three numbers now. Now let's take for example now I do something like image, and then I'm going to say image number, or maybe let's say image pixel, for example. Let me just use that. Now it's going to be what is that what is that happy girl's image again? That is image, right? So that's what we read here. Wait, I'm just going to kind of comment this out so that it doesn't really make it stressful for us to see. So I'm going to say image, and then now watch. When I kind of print this, let me just print this again. Print this, maybe let's just print that again now, right? Now what you see that we have here is what we call what? Rows and columns, right? Rows and columns. So if I do something like maybe go to the, because this is what we call NumPy slicing. Remember when we taught NumPy, talked about slicing? I'll still show you that in a second now. Then maybe I'll ask it to go to row 100 and against column 200 and get me what is there. And then I'll ask it now to print image pixel. Now what's going to happen? That it's going to return the exact pixel that is there. In short, what we're going to do now, let's just create a random image. New, any image, okay? num MP dot once. Remember, we could use once, and then we'll pass in. Let's say it has like let me just do something smaller. I don't really want something so much. Let's say 3 rows and then 4 columns with 3 color channels, right? Something we can understand. So I'm going to say the data type is going to be, it's, of course, it's going to be 0, mp dot uint, okay? Uint 8 as the int integer. Now, this is the image, right? And then, of course, I could plot dot show this. I could plot dot image show this, image show. Let's see what's going to happen. Any image, because that's definitely going to take in a number array. And then it's going to give me this, right? So more kind of black. That's 11111. Because on that color channel, if you have something like, let's say, for example, 0000, right? What's it going to give you? It's kind of going to give you something closer to black. I don't know why this is not kind of letting me do this. Okay. And then if you have something like 255, 255, 255. Remember we talked about color, we talked about color iterations and all of that, right? That's the three color channel. That's RGB wheel, how the RGB wheel works. Once that TensorFlow, so RGB. Now, what you're going to see now is that this is going to be 000, of course. That is going to be maybe very black, and then of course if you have let me just kind of multiply this here by 255 and then run this maybe with plot dot axis off, and then you're going to see it's white, right? So this is equal to what? White, right? And then this is equal to this is going to be equals black, right? So this is actually what you need to understand. So the color goes in this RGB, red, blue, green. But now for the case of OpenCV, it's going to be the other way around. So if we are modifying numbers and all of that, we are thinking BGR, blue, green, R, right? So this is it now. Watch, I just kind of multiplied everything inside this array now by 255, and then I'm having pure white, which is 3 color channels of what? These are kind of 3 color channels that has numbers of maybe that has numbers of 255, 255. Let's kind of see what that array looks like. Okay, let me print, because we're trying to talk about how to modify and access pixels, right? Modifying and accessing pixels, please. Remember, that is where we are. Okay. Okay, so I'm just going to write that down here. Where am I going to write it? Um, okay, I think I'm just going to put that here. Modifying and accessing pixels. Okay. All right, so that is definitely going to be that now, right? So if we print, like we said here, if we print any image, let's see what we're gonna see now. And then also print type of any image. Now, this is just what it is, right? It's a numpy array, and then it has this. Now, what we are trying to talk about now is accessing or modifying. Now, if we want to access an element here, or want to access maybe a pixel, because each of these is a pixel. This is one pixel, this is another pixel, and each of one want to know the total size of pixels here. So print any image dot size. And then it's going to currently we'll have 36 pixels here, right? And each pixel contains its number. Now let's say I want to access maybe this particular one, right? So now that's what I'm saying. I'm going to say any image pixel is now going to be equals to what? Any image. Now go to 1, go to 0, 0. Print any image pixel. I see it gives me that. Now, that's what we call what? Assessing the pixel. So this is the exact thing we can do to the image of this particular young girl here. Because, of course, these are numbers. Look at it. They're all numbers. These are just numbers. So each of these number is a tiny block. So if you look at now, this whole part of it, you notice that it's white, 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 white. That's why most of here now is 255, 255, 255. Then somewhere in the center, you're going to be having what? Something like maybe 12, 13. That's why when I try to assess the 100 to 200, you see I had 27, 50, 112, because that is the number that is assigned to something at the middle. That's why it starts from BGR. So if I want to kind of convert everything there to black, I could just, once I use a variable to store that particular part that I'm assessing, then I will assign it. I will do what we call, list are mutable, right? We can list are mutable. If you remember when we talked about list and arrays in our Python discussion, we talked about is mutability. It means that we can change, we can remove, we can change, we can replace, right? We can access it. I don't love that. Unlike other data structures like sets, tuples, maybe tuples, which might be immutable, right? But then NumPy arrays are what? Really, 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 really what? Mutable. So that's actually that. So what we're going to do now is, uh, since we now have that insight, the next thing we'll now do now is we are now going to try to change something inside that arena. We'll try to change something inside it, okay? So that's why one of the reasons why I use this kind of, one that has 36 pesos here. Uh, that is, of course, going to be, of course, that's why I used this one that has 36 pixels, which is going to be easier and faster to understand. So what I'm going to do now is so what I'm going to do next now is I'm going to kind of now say, okay, since we've got that done, let us kind of do some iterations and changes. Now I'll be watching this now. Watch all of this now, right? Now, that any pixel image, I've assessed it and it has given me this now, right? Now, what I can do now is I could just add this thing here to assign it to maybe 967 0. Let's see if that's going to work. Okay, good, good. Now, that's what it has given to me, right? Okay, now let's kind of change it now properly now. So what we're going to do now is I'm going to say this now. Go to now I'm going to call it X pixel. I'm going to use X so it doesn't confuse you. I'm going to say choose probably get pixel, right? Is going to be equal to any image, because that's still any image, right? Any image at or rather, what I'm going to say is any image. Let's just do that directly. We say any image at 0, 0, right? Change it to 89, 56, 76. Change it. It will say yes. Now let's print any image. Are you seeing it? It has now changed it to what? 89, 56, 76. That is what we are saying, okay? And this is quite very important. Now, what about, okay, I don't want to change, if I could have run this now, it's could still have worked there because, some of what we are doing now is we're using a procedural style of programming, right? So it's running line by line. Now, if I want to change multiple columns, right, at the same time, then I can now apply what we call, I can now do what we call slicing, right? And then, of course, the subsequent column is going to do it's going to perform some NumPy slicing. You know what we mean by NumPy slicing? And then it still has to match. You must make sure it matches, right? Because we talked about that broadcast and all of that. So let's say, for example, I want to do go to any image, go start from start from, although this is just kind of small, so I'm going to say start from the beginning to one in the rules. I mean, it will go to the first rules. It will go to the first rules, and all of that. And then start from here, maybe, of course, do everything for this and then equal to maybe 0, 0, 0, 0, 1. Let's see if that works. So now watch, say print any image. Now you see what it does. It starts from the first row. So this is for rule start, rule stop. Let me kind of explain that. So I'm going to say, in terms of slicing, let's say we have an image. So this is going to be rule start, rule stop, and then okay. So that's actually what it does. So you see that it will perform some kind of slicing. And then, yeah, you see that that image is kind of changing and all of that. So those are actually very, very important. And we might want to ask, okay, if we perform uh, if we kind of do some visualization of the resulting image, now what we are maybe probably going to see, maybe if I say plot dot, I am show, and then I pass any image, because it has to be an array, and then I say plot dot axis, and then I kind of turn it off. Let's see what's it now. Beautiful. So now you see that this part now is now colored black because we have now sliced it. I seen it. So this partner is now colored black. So you see how it works. This partner is now black because it kind of started here from the beginning to the end of that column. So beginning to the end of the column, but then it starts from the first row all up till the what? The second row. So that's all up till row one, right? So that's actually this first one. All this first one now is row one. Everything here now is row one. That's row zero, right? Which is this one. So, but then it took all the columns. All the columns were changed. All the entire columns were what? Were changed. So, now, this is actually very key to see that. You see that we've kind of met this image now, altered some things inside of that normal white image that I did show you now. So that's what we call what? Assessing and modifying pixels. So we can assess the pixels and then we can modify it. Now, the next thing we are going to be looking at now is how we can convert color. We're going to be looking at color conversion now because we've been seeing BGR, RGB, grayscale, and all of that. So now let's look at color conversion, okay? So we're going to look at what we call what? Color conversion, all right? So color conversion, I'm just gonna like that, and that's going to be that. Now, what do we mean by color conversion? Now, ordinarily, I told you that OpenCV does return its images as what? RGB, no, BGR. And one of the things you need to understand is that OpenCV can give you access. It can give you access to change your what? It can give you access to change your colors to your image color to maybe to RGB, it can allow you to change it to grayscale or BGR or whatever, right? Now, I'm just going to go on the internet now. Let's just go and get another image, something that's quite funny and engaging. And I'm just going to go to internet and we're just kind of trying to, maybe I'll come here. Maybe we're going to look for image of a dog, right? Let's just look for that. And that's the image of the dog. So I'm going to open my VS Code and try to drag this image here, image of this dog. Okay. It's okay. It wants me to save it first. So let me kind of save the image. I think I'm just going to choose a better dog. Okay. And okay, let's choose this dog. All right. So I'm just going to click on that. I'm going to save the image as well. And okay, it comes as AVF file. Let's try and see what can happen with that. And dog happy. Okay, so I'll go back to my VS Code. I'm going to minimize this. We'll drag that dog here. Well, good. Okay, that's the extension. And then that's the size. And then the next thing we're going to do now is, since we have that size, I'm going to come back here now. So now let's try to read the file. So we're going to say dog image is going to be equals to cv2.imread. And then we're going to pass in dog. Now it's not inside the any folder, so say dog avf. And if we leave that, okay, let's say plot.imshow, and then we pass in dog image because it's going to take an array, and then we're going to say plot.figure. Let's just kind of reduce figure, now say fig size because that dog size will be very big, and then let's say plot.axis then of plot.shoe. Okay, what's the issue? And CV2. Okay. And then let's see CV2 dot color dot imread. Let's color. And okay. What does it want us to do? Dog happy.aviv. I think the file part. Okay, let's just kind of do something now. So what we're gonna do now is I'm just gonna come down and that worked well. So okay, dog image or shape. It doesn't still start. Print type of dog image, non-type. Okay. And then what we'll do is, but let's say we have dog, let's say dog new image is supposed to include random zeros, and then we have on 119 and 5, 6, and 3, and then impedance u int it print type of dog new image. Okay, u int the number array. Cool, cool, cool. So we just kind of go up and then inspect. And then we would, okay, it's not reading that file. Okay, so let's see if we can try to rename the path. JPEG. Okay, so let's go back. We're just gonna let all of them run. And so we're just gonna print something random to be sure that works now. And just to be sure this is not in any folder. It isn't. And photo, so we're gonna add photo.png. Array. Okay, so that's actually from the file that we are choosing. Let's kind of pick up another image from the internet and let's pick this. This is a web file. So let's kind of take this image. And then we'll see new dog. Okay. So we're just going to minimize this. We have several images right now. And I think we could just make our way with this because of the file type. And then I'm going to add this dog then. So let me just kind of type to this. Happy dog. Is that dog happy? New dog. Let's just call it new dog. I think that's better. Okay. And I'm just gonna come back here. So dog image of new dog. That's new dog JPEG. Okay. So we're gonna uncomment that. Probably we encountered that due to file type. Because it's kind of literally the same thing that's what we did. And then the next thing we're gonna do now is, so how do we kind of convert the color, right? And how do we do that? Now, that's what we're going to be learning now, right? Cool. Okay, I'm just going to delete this. Okay, all right. So now, first one now is to convert to BG to convert from already it's already in BGR, right? So from BGR to RGB. So we're going to say RGB dog is going to be equals to CV2 dot convert color. Okay. And then we're now passing the dog, the part, that's the part, which is dog image, because we must first of all read the image. Don't forget, we must read the image first. So dog new image. I think I have that saved here. We say dog image. And then CV2 dot uh sweetie dot color. So it's going to be BGR to, what are we taking into to RGB, right? So we look for BGR to RGB. Okay. So when you say plot dot show fixed size, I think I'm just going to increase plot dot figure rather. Let's say fixed size is equals to 6.8, and then plot dot I'm show. And I'm going to pass an RGB dog. RGB dog, and then plot dot axis of plot dot show. Now that's going to give me the real color of the dog. Okay, so I've kind of converted it back from BGR to RGB. Now, one of the things I want you guys to know now is that it is possible for you to access the color in each particular for each particular dog item. Let's say, for example, now we have this as a numpy array. I could say RGB. Now I will say, give me RGB dog, right? Now give me the give me the shape. Let's know the shape. So it's 387 rows and 516 um columns with 3 color channels. Now I want to see now what I'm this is this shape, right? Now I want to see because if I'm accessing this now, this time around now is now RGB, right? So I want to see, okay, if I go back to dog now, it's no longer RGB now. I've gone back to the dog. Right, I've gone back to this dog now here. It's still RGB anyway. Yeah, because I kind of just removed the shape and then moved it to RGB dog. Now I want to see what is in the 100th column, in the 200th row, and in the because it's three color channel, right? And one. Let me know what is inside there. Now, what is there is 178. Now, watch. If I cannot remove this now, right? You see 167, 167, 168, 178, 107. Now, if I want to see what's in the zero, that it gives me this is what? This is kind of the property where I'm kind of use a comment. This is the what? The blue channel. So I'm going to print, I'm just going to print this. So to make some sense to me. Show me the item in the red channel. So RGB now, I want us to really understand this now. So I'm going to say, show me the, maybe you could call it the number of pigs or whatever thing. The item in the blue channel, RGB, right? Oh, green, so that should be green, sorry. And then, hold on, I'm not done yet. In the RGB blue. So this is going to be 0, 1. And then this is going to be 2, right? Cool. So now this is the red, and this is the green rather, and this is the blue, correct? So RGB. Now when I kind of print this, this is going to give me 168, 178, 107. So that is why we have, if I kind of do this now, maybe I do show me for the 100, 200, and then just only all of that. Just show me the pixel that we have there. You see that I have 168, 178, 107. That is the item that we have inside of that particular that's that particular array pixel. All right. So there are actually a lot of things we could want to really understand inside of this, like so many so many things that are actually really quite very beneficial and important. But so that's actually that, right? Now, most times, sometimes we might want to change, when we'll be doing resizing, we might want to change the width and the height and all of that. Also, that time we could just use maybe 0 and 1 of just that. So that's going to return only this, the height. This is the height, and then this is the width. So each time we talk about the height, anytime we talk about the height, I'm just going to show you something. Anytime we're talking about arrays, I'm just going to try to write. Anytime we're talking about arrays, for, don't mind my horrible handwriting, for images, right? Just understand that what we have here, we usually have the height, and then we have the width. So, sorry, I don't know why. I was mistaken touch to that. So this is actually what you need to understand, right? Cool. And now this is the what? This is the rows, right? I've always been postponing getting a drawer, right? Something I can use to draw. But if you're watching this video, you can always support us. That's going to be much appreciated. So this is the columns. I'm going to circle back to this, but it's quite important for us to note, okay? All right, so I'm just going to go back to VS Code, and you could see that I've kind of tried to assess this element, basically, excuse me, what it is, how to actually get those, and basically that's that. So now let's convert from BGR to gray. So we're going to say gray dog. Now we're going to see kind of something. Gray dog is going to equals to, so dog, right? Is that the new item that we kind of give the dog that name, dog image. Okay, so dog image. So it's going to be cv2 dot convert color, right? And then we'll pass dog image, and then instead of a dog image, yeah, instead of the dog image, so we're gonna have something like maybe and yes, for the dog image, it's gonna kind of give us a cv2 dot color, and then because we're kind of showing dog image, so we have kind of color, and then we have BGR2 gray. Okay, so that's the gray dog. Now you see that for grayscale images, right, it doesn't have the 3 dimension, it has the 2 dimension, so it's kind of shrinking, right? And this is one of the reasons why we'll be talking about when we get to interpolation. We'll be looking at how to use maybe inter area and maybe other params that are quite imperative. So we're just kind of converting the color, right, to gray, and we've not want to resize. I want to say print. Okay, I'm not printing anything problems. I want to print the shape. And then what we can do now is a plot dot image show. I think I'm just going to kind of plot dot figure to kind of have the fixed size. And then it's going to kind of be maybe we could say 5 and 7. That's fine. So image show of gray dog, and then we're gonna have plot dot axis. This time around we use false, and plot also plot dot show. And one of the things I want you to understand now is that I could also print some of those properties. We could access some of the properties here. We could say shape of this gray dog. Okay, so let's get the shape of the gray dog, and that's going to be gray dog dot shape. And then let's kind of assess what that is. I could see shape of the height of the gray dog, okay? And of course, that's going to be gray dog dot shape of 0, right? And then we're gonna print shape of the, because kind of we just got the height. I also want to get the width of the gray dog. So we're gonna say gray dog dot shape of 1, right? So I think we could just remove this first one. And then we're gonna print what other property can we actually access? Right, we could just maybe have to access, we could print shape of Now let's get the type of this dog. That's type of this breed dog image. That's going to, we're gonna have type of breed dog. Breed dog. Okay, so let's run that. And that gives us the dog. So we've converted that dog from a BGR to RGB, right? So we could still, now what happens now is that it kind of does some of those conversion. This dog, when we do gray dog dot shape, now you see that it is 387517. That's why we have 387 here and 516 here. And it kind of belongs to the class of NumPy array. Now, actually, these are actually some of what we need to be looking at and what we need to understand. I could go on and on, to explain some of these. But essentially, what I want you to understand now is that uh, this stuff here printed in another window, you just kind of need to know that there are actually a lot of ways you can actually access some of this. And you might want to print what the grid of is. Let me just kind of have the running array of this dog, and we kind of print grid dog. And then you see that it shows you some kind of a two-dimensional numpy array, and then the n dime that's going to try to get the n-dimensional array and then show that it has two-dimensional array. So this is what we might call maybe here. We can call this the dimension of this dog. Okay, that's 2. I'm just gonna put this here. Now, if you want to really get good with programming, you just have to kind of you just need to just kind of open your terminal and start coding. Now, but those are actually dot. What we want to do now is, now that we understand the dimension of this gray dog, and then we might want to perform some kind of uh if we want to access elements inside of this gray dog now, it's not going to be the same way we did it for the RGB. That's the dog, the color of the dog when it was converted from BGR, blue, green, red, to RGB, that's red, green, blue. So this time now we could say something like maybe gray dog, excuse me, gray dog, go to the 100th row and 200th row and get me what is there. Just get it to me. So it tells me that what is there is 167 because grayscale images just have one number, right? We don't have three color channel like maybe three-dimensional array. Maybe I kind of have 3 dimensions. Even if you kind of need something like batch, you're passing it in batches and then you have 3 dimension and they kind of iterate over it to maybe to slice that particular item to get some information. Of course, yeah, that's going to work. But here, just kind of feel free to use this style here to get it. Now, if I kind of want to get some kind of region, maybe I want to say gray dog, gray dog, and then I'm going to say start from 880, right? That's in the columns, and then down to maybe no, you can't go up, you can't go back. So it has to be from 109 and then stop there. Then go to the columns, start from maybe 20 and then down to maybe 78. And then what I want you to do now is change it to 0, 0. Now let's see if that's gonna work. Okay, it cannot work because you cannot you cannot broadcast an input of 2 by this 2, but then we cannot use 0. That's definitely going to work. And then uh if we were to kind of plot that, let's just kind of see what happens when we show that image now. Gray dog, gray dog, gray dog, okay. And excuse me, plot dot figure. Okay, and then I'm gonna fix size of maybe 6 and 7 and a half plot dot show. That's what's going to happen. Now, you see that some part of this dog has been colored black, and that's here. I've kind of colored that side black. So that's actually that. So 0 is black, 255 is white. Now, if I kind of change that to 255, watch what's going to happen that place now. This place is going to change to white. Okay, it changed to yellow. Okay, well, so that's fine. So those are actually what we need to understand, right? We could access a pixel, we could change it, we could modify. There are quite a lot of things, essential things we could do, whenever we are converting or changing colors or maybe performing any sort of changing, to our pixel, right? Or to our image. Now, the next one we're going to be looking at now, we're going to be looking at, since we've done for resizing, we might want to look at, no, we've done for, this is just kind of changing colors, right? We can want to do for resize. How can we resize images, okay? Now, this is actually a very useful method in computer vision, right? And OpenCV, where we kind of change the size of an image. We kind of remove some properties and then we resize and all of that. Now, but even before that, now there's also what we call the CV2 Windows rename. CV2 dot Windows rename Windows. So that should be rename Windows. If that works, let's see if that works. Okay, it doesn't have the attributes, okay? Renamed, oh, so that's renamed window. Okay, that's not bad. Now, what we're going to do now is, let's say, for example, we have image. For example, let me just show dog. Sorry, excuse me. So we'll have dog image. First of all, we'll read it. See to the IM read. I would have wanted to show us that, but probably I'm just going to do that later. So I have new dog image, and then we'll see cv2 dot im read, and then any color. Let's see what happens. What dot im show dog image. That's what it shows. Okay, so it shows us any color. I think this is kind of looking so well. This is a BGR. Let's see. Let's just kind of see. Print. Print type of dog. Okay, still an array. Now, if you look at this now, this is BGR, right? Now, what we want to do now is, what about if we want to resize this image, right? And that's what we're going to be looking at right now. So if we want to kind of resize this image, I'm just going to remove that. So what we could do now is we could say new size is going to be cv2 dot resize, and then we're going to pass in dog image, and then of course it's going to take it, it's going to take that in. Now it's going to take in some parameter. Now one of what this parameter is going to take in width and height. It's going to take in width and height. So now here it's going to be probably, let's know what the shape of this is first of all. So you say dog image dot, dot shape, right? So this is 387 by 516 by 3, right? So now I want to get the new size is going to be, I could just say dog shape. Let me just kind of run some mathematics. I'm going to say dog image dot shape. Now this one is going to start with the width. So it's going to be this height and width. But in terms of in whenever we are doing uh image resizing, because it's this some of these are actually very important, particularly whenever we are performing some kind of data augmentation in machine learning or deep learning, where we want to kind of produce more images. We could resize some, blur some, do what we call filtering, image blurring, and all of that. But excuse me. Now, whenever we're doing image resizing, right, it kind of takes in two parameters. Now, the first argument here, I'm sorry, first, now because this is CV2 dot resize. And the first one is going to be the image, and the second one is going to be the width, and then the next one is going to be the height, right? So if you want to have some kind of interpolation, we'll talk about that later. But I think this is actually what we need to know, right? For now, whether we want to shrink or want to expand an image size, right? They're actually parameters that are quite imperative for that. So I am going to now say so the first argument is the width, right? And then contrary to when you're checking the shape, second is the height. All right, so that is fine. Now what I'm going to say now, I'm just going to say dot shape of maybe 0. No, that is going to be 1 because that's the width. And what I want to do now is kind of multiply it by 2, comma. So let me kind of wrap it inside another this, and then I'm gonna have dog image dot shape, and then of 0 now multiplied by 2. Okay, so that should work. And then let me see, let's kind of print news. So let's kind of title this proper new dog size, right? So I'm going to say new dog size, the shape. You see that just kind of multiply this by 2 and all of that. And then if you say plot dot I am show, okay, so if I do plot dot I am show, and then I pass in of new dog size, lots dot axis of plot dot show. Nice, that's it has resized the image, right? Compared to what we have. Now, I want you to understand something that we could decide to shorten this image. And of course, what we could do here now is we could say that the height width is equals to that the dog image dot shape, and then this is going to be because the height is usually the first one, and then the width is the second one, right? So I'm going to say dog dot shape. No, the height is usually the first one. So this is going to be dog image. dot shape, and then I'm going to pass in 1, right? So we could want to swap that. That's usually, right? Then I'm not going to see, now I'm going to see, now I want to do the half of the size. So I'm going to say size is equals to 0.5. And then I'm going to see new dog with W. No, I'm not going to touch W now. And I'm going to see half width. And so let me say new width is going to be equals to half. That's going to be W. I'm going to wrap this with an int. I'm going to say an int of W, and that's going to go with, maybe just multiply it with size. That should work. And so that it's going to return an int for me. And then new height is going to be equals to the integer of height multiplied by size. Okay, maybe you might want to call this size, or what a new size, whatever thing you want to call it. So I'm going to now say here that half dog size is going to be equals to now cv2 dot resize, and then I'm going to have what am I going to do now? I'm going to pass in dog image. Then I'm now going to have my new width, and then my new height. Okay. I could want to talk about interpolation, but I'm just going to talk about that in a jiffy now. And then I'm going to say print half dog size dot shape. And it's kind of slices it down. So you could just take a look at this here, because that's 387 divided by 2. Because when you multiply this by 0.5, it kind of divides it by 2. And then it's only going to return an integer, right? It's going to return an integer. Now, you might want to use the round down function, right? That's the integer division function. But that's still fine. Maybe anytime I want to round down, and that's also good practice. But I don't think I'm just really going to be covering so much of that in this video, but just trying to keep it very simple for anybody who is kind of trying to get started with OpenCV. So I think that is just basically going to be that. Based on that, if there is kind of anything, of course, I'm definitely going to address that. But yeah, the next thing I want to do now is, since we kind of know how to resize, how about what are some of the best practices if we are resizing it in terms of maybe we are shrinking or expanding the image. Now, whenever we are shrinking, now there's an argument. There is an argument called interpolation. Interpolation, which is what I'm going to talk about now, right? So what interpolation basically does is that it kind of tells us how uh, OpenCV should handle the shrinking, maybe from center, or maybe kind of, if it is something that we're expanding, what is the best interpolation approach for us to kind of use? And of course, that is what we are maybe kind of looking at now, because if you're shrinking, you might want to use, if maybe, let's say, for example, you're trying to reduce the size, you might want to use cv2.interarea. And then so let's say, for example, now here, when I was kind of reducing the size, I could just pass interpolation is going to be inter area. And I'm going to run that. I think what is the issue? Okay, sorry. I think that was a mistake. Probably I didn't add CV2 dot that, okay? And I'm kind of check if I kind of spelled that correctly. Okay, okay, good, fine. I didn't spell it correctly. I mistakenly put a bigger I there. So this is actually what we use whenever we are shrinking down. Like now we just trimmed it down half the size. So we use inter area for interpolation whenever we are shrinking it down, right? Now, another one we could use now is that we could just say, okay, let us change the size. Uh, let's see, dog again. We'll call this dog again now. Then we're going to see CV2 dot resize, and then we're going to pass in dog image. And then this time around, like we said, it's going to take in first argument for width 455. And maybe let's say we want to expand 600, and then we want to expand to 718. And then interpolation now is going to be equal to CV2 dot. Now, if we want to know, one of the general purpose we could use usually is we could use interlinear, right? We could use interlinear. So we could say CV2 dot inter. Now you can also see some of them interlinear. All right, and then but I am sure, and then we're gonna pass dog again, lots axis off, and then now you see it's kind of just kind of try to kind of increase that, but change the shape because of the size. Now we also have another one where we call intercubic, we call it intercubic, okay? So I'm just going to put those down here. I'm going to say interlinear is usually whenever we want to shrink, no, not shrink, no, expand, or rather, it is a general purpose. So it's a general purpose style that we use. Intercubic is also another part, it's also another one that we use. Oh, this one is usually, but this one is very slow for me. So that is that, right? So the next one we're going to do now is since we actually have this now, right? We could want to do the because now this is basically most of what we need to know about resizing an image, and we could want to do some slicing, right? Let me call this. Let me see. Maybe this is slicing an image or cropping. Now, ordinarily, let me just kind of put that. Now, ordinarily, for us to slice an image, like I said, we just have to use the numpy or cropping. Let me just kind of use, I think that's kind of a better word to use. Cropping an image. We just have to use the numpy slicing approach. So just use the numpy slicing approach. Okay, so you could see, for example, that your new image is going to be equals to be your dog image. Let's say dog image, and then just give us from 200 if I thought it's up to that, one to the end, and then maybe way to the end. Now just kind of so that's actually we've cut out that part. So I'm gonna say plot dot image show. Let's see if what is going to give us new. Okay, so that's it. So it's kind of cut out some parts. And if we just do the starting, let's just increase this to maybe 8. Uh, let's just increase this to 9 and maybe 190. Now you could see now that we're gradually cropping out the image. It's starting from row 119 down to the end. And then let's say we want to take it from, want to cut out the head. Let's move it from maybe 100. Let's maybe from the end, remove stop at, stop at maybe 200, let us see. And that's it. So you see, that's how we do that. And of course, there are a lot of things to do. So you could see that this way now I'm trying to crop the image and all of that. So that's it. So like I said, you use numpy slicing approach. I've already written that, writing that again. And then the next thing we're going to look at right now is I'm just going to show you how we can draw an image, right? And that's kind of an important part for you to really understand. All right. So drawing on an image is something that is quite very useful and important to know. So I'm just going to show you that. And of course, it kind of takes in some arguments, and those are what we are going to be using in this particular session. So for you to draw on an image, it could be a line, and then it could be a rectangle, or it could be a circle and all of that. So maybe we'll just create one blank image, and then I'm going to, of course, draw on it, so that I'm just gonna see if you guys can kind of catch up with what I'm going to do. So I'm going to start with kind of a line, right? We'll create an image, draw a line on it. Then I'm going to explain what the arguments are. And of course, then we could do that. Now, let's see. I have, because this time around we're talking about drawing on an image. So this is drawing, so let me show you, drawing on an image. So how to kind of draw on an image. And now, one of the things you need to understand for you to start drawing on an image is that you need a blank image. Let's kind of just create an image, random image. So I'm going to say canvas. I'm going to call that image canvas. I'm going to say mp.once. And of course, I think it's going to be preferable for me to make it a white image so that you can see how I'm going to color it. So I'm going to scale about the ones. And sure, that's going to be kind of a black image because the canvas usually returns a white image. Look at this thing now, it's white. So if it's 000, then that's black. So once, so it's going to have 450, 680, and of course, three color channel, not three. And then the data type is going to be mp.uint8. Okay. Now, this is an array, right? So if I cannot multiply this now, it's going to give me white. Well, let's kind of leave this way. Let me just do plot dots, plot dot I am show, and then I'm going to pass some canvas, right? There's a plot dot fixed size, not that. So plot show, let's see what it's going to show. So it kind of gives me a black surface, right? Which is fine. There's no issues with that. Now, let's just be watching this now. I'm going to turn off the axis, plot dot axis force. All right, now I'm going to draw on this particular surface. Now that's what we want to do. Now, how do we actually draw here? Now, to draw here, we're going to say line. We're going to say line, or we probably could just say CV2 dot line, right? And then we're going to now pass in the image. So it's going to be canvas. Now, what are we now going to draw on it now? So passing that image, and then it's going to take in some parameters. I'm going to explain shortly what those parameters are. First of all, I could just give it 50 here. I could give it maybe 70 here. And then it's going to take in another params of where it's going to terminate. Now, what is yes? This stands for the x-axis, where it's going to start. I'm going to show that shortly on my Microsoft whiteboard. And then where it's going to terminate at y. Then just think about plotting. So this is not like the kind of normal, maybe the usual coordinates. No, I'm going to show you how it works. So maybe here starts from 200 and terminates at 300. And then the next argument is going to take in now is the color, right? Which is usually a BGR. So here now, maybe I could just say 255, which is going to be white. And then 0, that's red rather, 0. That should be blue, well, because that's BGR. And then it's going to take in another last parameter, which is 3. Now, let me explain what these things are now, right? Now, first of all, the canvas there, that canvas that I explained here it illustrates the image we want to draw on, right? Now, the 50-50 there, it kind of illustrates the starting point, which is kind of the x and y. So x starts on the top, right, going down, whereas y is going to the left. I'm going to show you that just like I said, promised, okay? I'm just going to explain the argument. So I have 200 there and 300. That's kind of the what is going to illustrate the ending point, right? So still x and y. And then we're going to also have that 255.00 is going to be the color channel. Okay, so it's usually BGR. All right? So this is going to be pure blue. right? And then because remember, it says OpenCV, what it's returning. And then that thread there means it actually illustrates the thickness of the line, right? That's the thickness of the pixel, thickness of the color, which is the pixel. That's that line that we'll definitely put there. So essentially, that's actually what we need to get. And I'm just going to run that. It's going to return an array. And what I'm going to do is, I think I could just assign this. Let's just kind of assign it. See, drawing is equals to this so that that doesn't return anything. So we're going to plot the IM show. Remember that it kind of returns only an array. I'm going to say drawing plot dot axis, and I'm going to turn it off. The plot dot show, and then of course that's going to give you a red line. Now let me explain how that numbers work, particularly this 50,50 here. Now, if you kind of go to this Microsoft, if I kind of go to this whiteboard here, now this is what we have. We have something like this. I'm just going to show you. Let me just kind of give you this, right? So don't mind my, I think I'm just going to draw something better this time. I have to be serious. Okay, so I'm just going to draw something like this. And I'm going to draw something like this. Okay, let's just leave it that way now. Now, if it is going this way, right? If it is going this way, let me just do it here, right? This is the, this area now is what we call the Y. Now, if it's going this way, this is what we call the what? No, this is the Y, actually. And then this is the X. Okay, so let me just kind of clean that up. So do I have this way? Don't know why this did this. So this is what we call the X, right? And this is what we call the what? Y. All right. So now when we say X now at 50, so just think about 0, 1, 2, 3, 4, 5, maybe 10, maybe just think about it as 10, 20, maybe 0, 50, 100. So this point is 50. Excuse me. So that's why maybe if we enter the first value now and it's kind of 50, and then we'll have another maybe 50, right? So this is going to be 50 for X. Then let's say for Y, we have 10, 30 here, and 50, for example. So this 50 down to this 50, this is where it takes the first line. Now, let's say we have where it's terminating. I will say 100, and then we kind of call maybe 200, right? Now, what this is saying now is that this is going to be maybe somewhere here is 100, and then maybe somewhere here is 200, and that's probably somewhere here. And then it draws that line to that part. So that is what we mean when we talk about this, right? So at this point here, X is at 50, right? Y here is at 70, somewhere here, all right? And then kind of takes X at 200, so it kind of moves to somewhere here. Also, I don't know why I'm kind of collapsing that. So here, And then you see that Y comes really down, which is here at 10. So it kind of draws that line. And that's a red line. And why it's returning a red line to us? Probably so that's an RGB rather. So that's RGB. Okay, because this is 255, that's red. So RGB. So probably lots of updates has been made. And so that's actually whenever we want to draw a line. But how about if we want to draw a rectangle? So we're gonna say uh rectangle drawing is going to be equals to CV2 dot IMShow. No, not IMShow now, so dot rectangle, right? And then it's going to take in parameters now. And that's some of the arguments it's going to take in now. It's first of all, I'm just going to kind of put in just almost similar thing there. First of all, the image canvas. Then, of course, you have 100 by 100, and then which I'm going to explain shortly. And then you kind of have maybe you have something like maybe 400. Let me just kind of use maybe 300, and then of course the color. So that's going to be 2. Let's just kind of keep it at the center now. 255 and then 0, and then the thickness here. Maybe let me just make it 2. Okay. All right, so what the next one we're going to do now is we're going to say plot.imshow, and then we're going to pass in. Before we do that, I think we need to kind of explain the parameters. Excuse me. So the canvas here is going to be the image, right? And then now that first 100 and 100, whenever we use that, now it's going to be the top left corner of the rectangle. So it's going to be the top left corner of the rectangle. And then, of course, that 400 by 300 is going to be the bottom right of the rectangle, and that's usually X and Y. And then which is going to be, of course, X and Y. And we're going to see what that's going to look like. And then I'm going to see probably our number 0255, 0. Of course, that's going to be a green line. That's going to be a green line, which is the RGB value for the pixel, the rectangle line. Rectangle, that's the green rectangle. I think that's best practice. And then 2 is the thickness of the pixel. Now, let's kind of run that. That saves. What we're going to do now is we're going to do plot the IMShow, and then I'm going to pass in rectangle drawing, and I'm going to plot dot show. Of course, we probably could just turn off the axis. Let's see how we can actually just manage it. Got a figure, fixed size of 6 and 8, and then plot dot axis is going to be turned off. And then let's just have that. Now, this is something we are going to explain right now, right? And I'm kind of going to explain how we got this now. Now, first of all, if you look at this now, we have 100 X, so that's maybe X at 100. And then we have another X again at 400, which is going to be here. right? And then we have y at 100, which is here. And then we have another y at 300, which is here. So what it's going to do is just going to join the line. So I have here, here. So it traces it to where X is. So that's here, it meets it up here and here. So it's going to draw that line to that part and all of that, okay? So it's just kind of simple now saying Y is at X at 100, which is here, Y is at 100. So it picks it up here, right? And then Y is at 100 and 100, okay? So that's 100, 100, 100. So this is 1 point. And then again, X becomes, now because if you kind of look at this first one, I see that we have two lines there. But for the fact we're using a rectangle, what we need to understand is that we're not picking, we are joining, we're going to join the lines. We're going to join it. We're just going to join it, right? If it's line, it's just going to draw only one line across the multiple points that it's met, right? But here we have X at 100, right? We have X at 100, which is here. That's here. Somewhere here anyway. And then Y is 100. So that means it comes here now. So they met here. And then X again is 400, which is somewhere here. And then uh, Y is 300. Now they now meet here, right? So instead of joining that line here, we'll kind of draw it up to meet where this one met, and then also draw it down to meet where this one met. So that's the way. All right, so that's that for line. Also, we can actually do for circle. We could do drawing circle if that's the name. Just gonna check. Circle drawing. We'll say circle drawing is equals to cv2.circle. And then of course we're gonna pass in canvas. This time around, it kind of takes something strange and all, but that is, we're having 350 by 400, and then we're having 80, which is the radius, but we'll talk about that in a jiffy. And then we're having 0, 255, 255. Now, this is going to mix up the color because I'm gonna keep typing 355. And then of course, the thickness, which is, maybe we could just write 3. Now, what this thing means now is that I'm just going to explain the argument. And some of what I'm going to expect is that canvas, as usual, is the image we want to draw. We want to draw a circle on. And then, of course, we could have, the next thing we could have now is, we'll have that 350 there, and then the 400. So what does that imply? That implies simply the center point of the circle. That's the X and Y. Okay, and then the 50 there. Okay, that's 80 actually. It's going to be this. This is the radius of the circle. And then yeah, what else again? I think the 0, 255, 255 is just kind of the color channel of the circle. Okay. Excuse me. And then 3 is the line thickness. So now what happened now is that's fine. So plot Okay, I'm just going to run this on another line. I'm going to say plot.figure. It's a fixed size of 5 and 6. And I'm going to say plot dot I am shoe. Now, this is going to plot I am shoe axis. I am shoe plot dot axis false plot dot show. That's if you're running on a normal, if you're not running this on an interactive Python notebook. And plot the I am sure circle drawing. So we need to pass the argument there. And you could see that, right? So you see where it starts at 350, 400. So it comes at that point. That's the center point here. Here now is 350 and 400. So if you want to kind of bring it up a bit, maybe I want to take it to this side, then bring it up. Now this is what I'm going to do. I'm going to change this to something like 100, and then maybe just take this to like maybe 500. Let's see what's going to happen. It's going to take it here now. Now if I run it, I see. So somehow, you see that it kind of overwrites that previous one. That drawing has already been embedded on it. And that's one of the things you need to be really careful about, okay? So that is that. If you want to kind of draw, and then of course the radius is 80, which is the radius of the circle. Now actually those are that. And also the other things we could do too, we could write something in an image, right? We could put text in an image as well. That's still very much possible. And I'm also going to explain the arguments as well, just like we talk about this circle and all of that, because I think it's something that's quite really very important. And probably I couldn't write something anyway on this image now. I'm going to use, I'm going to say writing, or maybe let me say text. Text on image is equals to cv2 dot put text. So it's going to be, I think it's going to, that object is going to put text. I'm just going to use text, and then it's going to take it as usual, canvas, and then I think I could just kind of bring this one down this way. And then, of course, with the text that you want to write there, maybe I could write this tutorial on OpenCV. And then I'm going to take comma. I'm going to say cv2 dot. Now, this is where you now have to put the font, right? The fonts. And now there are actually quite some different, default fonts that you need to know. And then, of course, this is going to be the hash. I'm trying to just kind of spell out. And thinking. Trying to think it out. Hesha. Simplex. Okay, font underscore Hesha. Simplex. This is the name of the font. And then the next thing is going to be the font scale, 1.5. Maybe it's going to be 1.5. I think I could just make that 1.5. And of course, the color, if you want it to be white, times everything has to be 255, 255, 255. Okay, that's the color, and then the thickness is going to be 2. Maybe if I want, and then probably the line type, maybe cv2 dot line, maybe that works. Okay, so we're going to write that. Of course, that's going to run without issues. Okay, what's this saying? It can pass bad argument and function put overload resolution failed. Okay, let's see if we can just comment out this. It still stays. And then what we could do is put task. What do we want to do now? And okay, so this is kind of our size. I'll try to do something. I think it could be that there is not enough space inside our diagram. But I'm just going to try to comment out this argument because it should run a default. Okay, wait. No. Okay, so it's not the assignment. Okay, so what we're going to do now is we're going to just quickly create a new image, right? So we're going to call this, maybe let me just kind of comment that out. Let me just kind of create a new image in a Jiffy. And I'm going to call this image new image cv2 dot I'm just going to np dot maybe the ones, right? And of course, it could still be zeros. It could be zeros. And then it's gonna have 900, 600, three color channels, and then data type of np.uint it. And then that's the image. I'm just gonna pass it here. New image. And see, oops, text. So happens. And I think that could now be from there's comment that also it's alive. So basically, actually, this is actually what we need to understand uh, to help us. It's kind of help us get some of these things done. I'm just going to put that back there. Okay, I think we made a mistake here. New image, not just to be sure. What could be the issue? Can't pass org argument, doesn't provide sequence. Input test. New image. Tutorial, open series, something. Okay, I think there's a mistake here. We didn't pass in. Okay, I think I realized where we are having the issue. Okay, we should have passed in an argument here of what it should be, right? 470. And I think that should work now. Oh, thank you very much, guys. I'm going to plug the show. The I am sure. And then we're going to pass put text. And then I'm going to say block dot. There you go. Fake size of C7. Plot dot axis. Plot dot show. That's it. So this is tutorial on OpenCV. So it kind of takes it from 50 and then down to 470. That's why, of course, you could see where it starts. So doesn't matter how much of this is, it's definitely going to stretch and, of course, give you that. So this is actually very important. Maybe I could have explained the probably the argument. So here now is usually the new image. The new image, okay, I'm just going to use this. The new image. Okay, I think this is a markdown. Don't want to use it on markdown. I don't understand markdown. So the new image is going to be equal to the image, right? And then of course, that's the next text there. The second argument, tutorial on OpenCV is going to be the second argument where you put the description that you want on the image. And then the next is that's the 450 by 470 is now going to be the dimension of the image. Not like the dimension, the number, because you could say this is the X and the Y axis, right? Where the image is going to be displayed. And then that's CV2. CV2 dot. So the font, this is just the font Hershey. That's font Hershey complex. You could choose other fonts actually. Just feel free to do that. So this is the font style. And then remember 1.5 is going to be the weight of the font. So that's the weight of the font. Okay. And then 255, 255, 255. That's the RGB color font. And then 2 is going to be the size of the font. Of course, that's what it's going to be. It's going to be the thickness. That's the thickness of the color, right? So that's it. Because we kind of, just to check, just to be sure of that, let's just kind of increase this to maybe 4. Kind of increase that to 4, we run it, and then we run it again, and I think it's kind of thicker now. All right, so remember this first 1.5 here is just the font scale, the scale of the font, whereas this one is going to be the thickness, right? So let's just take this one to 3.5 and see the changes I will see. Okay, around that, you see, that means it kind of has a higher scale now, right? So, not necessarily the size now, but the scale, right? So it's kind of bigger. So we'll kind of drop that to 1.5 and then 1.5. It still has the same scale. It still has the same size, but it's at a much more smaller scale. But please, it's quite very important for us to understand. And I think those are definitely going to be that. This is kind of the line type, the type of the line. That's why I have line AA. So that's that. So of course we could do CV2 dot I am sure. If you want to kind of show everything. And I'm just gonna probably you might want to just give it a name. Maybe draw in, run its canvas, and then plot the CV2 dot width key. Okay, I think I get where we had that challenge then. CV2 dot width key, and then it's going to be 0, and then CV2 dot destroy, destroy. So was not sure width key, width key. Okay, we spelled this correctly. Width key. It's going to pop up. So we'll kind of rename that. We'll let that run. And so I'm just going to show you something briefly now, how you can actually visualize with OpenCV instead of Matplotlib, I am sure. There are still other ways you can use OpenCV for your visualization, and that's one of the things I'm going to be talking about now. Before we talk about camera, we're going to get into video camera. That's one of the last things that we're going to be doing. Excuse me. And before we kind of check our flipping, rotating, and all of that thing. So we're just gonna let that load, and so while that's loading, could print. So let's try to print. So great. Getting into camera and just run that. I'm just gonna run that. It's kind of asking me to wait for this, and so we're just gonna wait for that. So what we might do is all right, so what we might do now is, so rather than wait for that now, what we'll do now is we're just going to kind of collapse that because basically we've printed everything that we want. And I'm just going to delete that cell. So let's just kind of run this and be sure this is going to work fine. So what we'll do now is, um, so we're just going to let this, okay? Welcome, just to be sure that load. I think our kernel is still, we're gonna restart it. Let's restart our kernel. So the next thing I'm going to be showing you guys now is I'm going to be showing you once we are done how to perform our OpenCV, how to kind of read a file with OpenCV, right? So you just say, for example, you have a file and then you want to call it back. Of course, you could just come in, could do something like CV2 dot, sorry, pardon that. So you're going to write the name. What's the name of the file? What name do you want it to take? Probably I'm going to say David image dot png. Then give me that numpy array. So that's going to be a numpy array. Okay. Sorry, I don't know. I'll just kind of mark that. So I'm just going to turn it this way. So that's it. So that's what kind of what I want to explain now. So we'll check out that, and I'm sure it's done running. Then I'm going to run everything to be sure all our dependencies are well loaded and of course intact. So it's kind of running and okay, I think we have done. Right, good. So let's say, for example, now we have a cat image, also mp.once, and of course it is 200, 300, and it has three color channel, and it's kind of a data type of mp.uint8, not 9, not 9, not 7, please 8. Then I kind of want to load this image. Let me say cv2 dot cv2 dot imshow. Let me say cat drawing dot jpg. Let's just see what happens. Let's see if that works. Let's see that work. Cat image, and of course that works. That's it. But then we can't really see that now. And that's just kind of an array. But let's say we want to kind of visualize this image now, right? I'm just going to go back, new doc.jpg, new doc.jpg. So that's it. So probably we could now do cv2 dot width key 0, and then cv2 dot destroy all. Destroy all. Now, okay, that's the name I've given to. Okay, trying to just let's just kind of remove this now and see what will happen. Okay, what is this saying? I'm sure. Missing required argument math. Oh. It doesn't have the. Okay, let's kind of use it for this cat image now. Let's say cat. Cat drawing. Then I'm gonna pass in cat image because it has to take a numpy array. I just really want us to see how the with key works. That's one reason why I'm running it again and again. So I can just have an understanding of how it works. So my computer is kind of very slow. And okay, so what we'll do now is let's just restart the kernel again. And those are actually basically that's what we need for this particular lecture. So that is that. My work is done. So we'll run all. And then we can let it get done. All right, so that's good. So now we're going to get into camera, right? We're getting into what? Camera. How to launch our camera. That's the camera. So now, most times we'll be talking about arrays, floats and all of that, right? Talk about arrays. Maybe we kind of just create an image and you can say the image is an np dot random dot random and then maybe 0 to 255 and then it has maybe 400 rows and then 600 columns and 3 colors channels with a detail type of np.uint of 8, right? Now, this is just one image, right? So kind of one frame. Now, one of the things I want you to understand is that when I open my camera now, I'm just going to open my camera now so you could see my face. If I go to my computer here and type camera, right? I'm just going to open it, but I'm kind of going to tilt it so that you can see me. Now, if I open this camera now, you are seeing an image, right? So I'm just going to close the camera. Now, what you just saw now is just some kind of frames, right? When you open your phone camera and you're picturing something, what you're seeing is you're seeing frames. Your computer is seeing several frames per second, right? So it's not just like it's seeing some things in motion, it's just kind of capturing frames per second. Do you understand? So yeah. And now that is what we're going to be looking at that now as usual. So we have what the video capture. So I could say CV2. Maybe I'm going to say capture. That is going to be CV2 dot video capture now because now we're going to be doing that's what we're going to be looking at now. What's video capture. Now it's going to take an argument of 0. And then when I run that, of course, I just kind of assign this to this variable, so there is no issue with that, right? Now, but if I kind of remove this now and run it now, it's going to throw out my camera. Now you're going to see that now. So it tells me the address where the memory address where that my camera is currently located at, okay? and then that's actually present. Is video capture. If is video capture, let's say for example, this now, print true. And let's say if video capture prints true, so it's true. So it means that I actually have that located, okay? So I'm going to say cap is equals to cv2 dot video capture, right? And then it's going to take a zero. Now, what that zero means now, I'm going to explain. We could have several cameras, right? And then, but this zero here means our inbuilt, it's kind of our inbuilt camera. Now, if you kind of put one, it could be maybe one might be an external camera, and then maybe depending on the number of camera and the location of that camera, right? So if cap dot read return, okay, now these are my functions. I'm going to print true, for example. Now what this means now is that what if cap dot is open, because it's opened, print true. So now it's, yes, so it means that we have that camera, right? And so that camera is actually available, right? So let's not kind of complicate that. So I'm just going to continue going, all right? So now we've now understood that what you could have, there are several things that you could have. You could have, we could look at camera properties, how to access some of the camera properties in your that whenever you unleash your camera, and then how to resize, manipulate some of the properties of your camera, and a wide array of things, how to get some frames and all of that, okay? So, like I said, when you print, if your camera is open, it's going to return true. So, that is just what that is. Like this one that I just did here, I'm just going to kind of remove this. So I just kind of ask the question. Print true, okay? Now, also, if we do print is, if we print, because this is for our camera now, right? Lookup dot is opened, right? It's going to return. Let me just put this in the environment. Checking if camera is opened. So that's what true. So camera is what opened. Now, so that's actually for that. Now, how about we now go into getting our camera properties now, right? So let's get our camera properties, because we're going to be training something very magnificent now, right? And we could get the camera's height, could get the camera's width, just to know what it is and all of that, right? So for example, now I'm going to start with the width of the camera. This is the width. That's the width of the camera. I don't know if I can spell that correctly. So I'm going to say uh, cap.get, and then we want to get it. That's what we want to get. Say cv2 dot cap prop. Now I want to know the cap prop the frame width, right? Now for the height, that's the height of the cap, the cap dot get. We want to know cv2, which is going to be cv2 dot cap camera properties frame height. Now, if we want to get the frame count, right? That's if you want to get the camera, that's the frame per second, which is that's the camera's frame per second. So we could say the FPS, that's the frame per second, of how much frame is captured, because it's something that is happening within split seconds. We could say cap dot get CV2 dot cap prop frame. You see, there are actually a lot of things we can get. We could get so many. There are so many methods, right? We could get cap prop FPS. I think that's what we might want to get. And then we could just print, because this is actually for the camera height. We could say, I'm going to use an F string here. I'm going to say the width of the camera is, then I'm going to use the curly braces. I'm going to pass in width, and then, and the height is, I'm going to use the curly braces. I'm going to pass in height. While the FPS and the frame per second is FPS. Okay, so when I print that, so this is what you have in my camera. My camera is 640 pixel width, that's the width, then 480 height, and then the frame per second is 30 per second. Each seconds, for each second, my camera captures 30 frames. That's that, that's that's phenomenal. So we could still, as much as we were able to get our frame, our camera frame, right? We could, that's our camera properties. We could decide to do what we call setting our camera properties, right? So I'm just going to use a markdown for that. So I'm going to say setting camera properties. Okay. And then what we're going to do there is, so then we're not going to use get, because get is to get. So setting now, we're going to say, for example, now we could say new width. We could decide, we might not really have to assign that, yeah, because it's not like there might be a place where we might want to assign. Probably we could say new width. Now it's going to maybe, I'm going to assign it to 1280, and new height is going to be maybe let's say for example 720, and then I'm going to say now cap dot set, and then I'm going to say cv2 dot set, it's going to cv2 dot cap prop frame width. Then I'm going to pass in new width, and then I'm going to say cap dot set cv2 dot cap prop. So this is the property of the frame height, and I'm going to set it to new height. Okay, so so that's actually that, right? So I'm just going to run that, and then it's going to return true. And then of course, so I don't actually need to assign that. and that's it. So I've kind of reset my camera now. But then I want you to kind of understand that not all devices do support this, right? And yeah. Now, how about now we want to now let's say, for example, we want to read our frame, want to read camera frame, right? Because basically what we are saying is that this camera now is kind of unleashing one frame. Oh, sorry, I don't know why I didn't spell that well. Can spell now. So we want to read each camera frame, right? So we want to be sure, first of all, that our camera is open, and then we can now know what is the size of one frame, because we have several frames. Think of it that during your matriculation or sometime in school, you had some kind of training, and then in that training, someone was telling you that, okay, come and take a picture, and they snap your picture, they snap you the picture, check them, and then after snapping you that picture, they now say, okay, come and check. Oh, I don't like this frame. Oh, I like this frame. Oh, please remove this frame for me. Or, can you change this thing for me? And all of that. Now, all those things are what we call what? Frames, right? So for each picture that the photographer snaps you, check them, think of it. It kind of captures only one frame, right? Then you will now start, that's why we'll now start looking at the frame. We'll say, okay, it is 100 by 400, and then the width is this, maybe other properties of things we might want to do, shrinking it. But then, this is actually really very important. And I kind of think this is something anybody must understand, particularly whenever you're dealing with maybe computer vision, maybe framing and all of that. So, how do we now check that, right? So, first of all, remember we will always have cap is going to be equals to video capture, right? And then when we set it at 0 at our camera, right? We're going to run this. It has to work. It said that video capture is not defined because we didn't ask CV2 dot video capture, but now it is defined. Now go. Now what we're going to do now, we're going to take return. Now we're going to say frame, right, is equals to cap dot read, right? Cap dot read, and then it's gonna take in that. Now, what this read method returns now is that it kind of returns two items. Return means if it is true, right? And then frame means one of those frames where we can now grab one frame from the camera. So it always returns two values, right? You must always receive two values, and this return value takes true. So that's why we can say if ret, right, print something like maybe camera opened successfully, right? So that's it. So you see my camera is opened. I'm not sure if you guys can see me, but I think I'm just going to close that. I'm kind of just going to, okay, let me just do something like cv2 dot destroy all in this. And I'm just kind of cap the release. Okay, I'm just going to use cap the release the camera. Yes, so it's kind of releases the camera for us. So now, like I said, if ret print if ret, okay, this is not this is another language, this is Python, so I'm going to say print camera opened successfully. Cap dot release. So run it, it opens and it closes. So it's opened successfully and it's closed. All right. So now, but what we are interested in now is the frame, right? Yeah. So this is what it usually returns. So anytime frame is false, that means if the ret is none, right, it means that the frame did not open. So there was no frame that was captured, just so you know that, okay? But that's quite really very simple and easy and no issues and everything is nice and it's nice. So the next thing I'm going to do right now is I'm kind of going to now say, okay, now, like I said, we're gonna have if red, I'm just gonna do that again. I'm gonna print F. I'm gonna use an F string to now say, let's get some properties now. Let's get the frame shape. That's that first frame shape that we have, which is going to be like frame dot shape, and then gonna print a string of frame data type. Let's know what that says, and that's going to be like frame dot data type. Let's run that, and that's it. So it kind of went back to this. So now let's see if we can just put that cap properties back here, because that was after we did this, right? And so we kind of reassigned it. Remember, this is very procedural. And then, so now let's see what's going to happen now, because yeah. Now you see, clearly, we now changed the shape here, because kind of, okay, cap is equals to video cap. Then we said new width is this. Now cap does set CV2 the cap prop frame width, set it to this new height width, and then set it to this new height. And then we say ret frame equals to cap to read. And then if ret print camera open successfully, then if ret, we said again that print F shape, then get out the frame. So you see that this is actually the new frame, and that's the picture the computer is seeing, and that's why it's kind of a three-dimensional array. That's going to be that. And now we can actually try a full camera loop, right? So we're just going to do a short practice here. Let me just kind of name this full camera loop. So let's kind of start afresh. Now, what we're going to do here now is we're going to start by getting the frame, right? We'll first of all get the frame. We'll first of all get the no. We need to get what the frame is, the frame width, the frame height, and then also we'll now set it to something else that we want, and then after we are done setting it to maybe another params, then we'll now kind of run a while loop and see what we can actually do in there. Now, the first one we're going to do, like we said, now we're going to do cap is equals to what? CV2 dot video capture. Now, pay attention, just pay attention here. And we're going to put it at 0, right? Because that's our inbuilt camera. That's what we're looking at. Cool. That's cool. Now, like, first of all, like I said here, now, I'm just going to say here is that we assign the object for the video capture device. Okay, cool. Now, I'm going to say, first of all, is if cap dot is opened, right? Now, here now is, listen, repetition is going to really help us. Now, check if the camera opened. Now, ordinarily, I could just print this now, cap dot is opened, and then it's going to return a Boolean, which is true, which is fine. And of course, I could say if camera, if, no, not camera now, if cap dot is opened, right? So that's it. So I'm going to print camera is available, right? Okay. Now that works. Now we'll continue here on this. So we're going to say now cap. Now let's get the frames. Let's get the frame. Let's get the frame size. Okay. So I'm going to say, probably I could just say height size. Height size is equals to CV2 dot cap dot CV2, right? No. CV2 dot cap dot. Now we're gonna now kind of because what we want to do now is we want to get that, right? So say cap dot get, and then we want to know CV2 dot prop property frame. That's the height, right? Cap property frame height. All right. So see the width size is equals to cap dot get CV2 dot the cap property frame width. It could also get other things. So we want to get the FPS. It's going to be the cap dot get CV2 dot cap property FPS, right? So we're going to print, we have an F string actually. So it's saying the height of my camera is the height of my camera is height size, and then the width is width size, and the and FPS is the frame per second. So we're gonna print that, and then you see. All right, now what we're gonna do now is this, because it's kind of procedural. It's procedural. What we're going to do now is we're going to say, now let's set it now. See, cap does set. Now let's kind of change some things now. So CV2 dot cap prop frame height. I'm going to change it now. Let's say, for example, I want to have our new height is going to be one. No, no, height is usually kind of smaller. So it's going to be 790, and then I think I can use camel case there. But new width is equals to 1080, right? And then we're gonna see cap dot set. Set it at new height, and then we'll now say cap dot set this as CV2 dot cap prop, then kind of frame width. I think okay, we kind of spelled something wrong, and it kind of stopped talking to us because it was wondering what we wanted to do. Okay, and then of course you're sure that if we kind of copy this now and then now paste this here, see the new height of my camera is I think, okay, maybe we could want to have assigned this. Let's just kind of assign this and see what happens. And then maybe, because it kind of looks like this returns a Boolean height is width, and then it's gonna have height, and then maybe here is width. Let's see what happens. It's true and it's true. Okay, so this doesn't return any number, right? So you can assign this because it's going to return a Boolean, and that's it. So that's just it. So we'll just have to leave that. I'm just going to remove this, right? All right, so this is what we've done now. The first thing we did now, we kind of we first of all confirmed if our camera is open, and then we checked, we confirmed that, then we kind of checked the height of our camera, the width of our camera, and then the frame per second, and then we checked that, we printed it, and then we kind of checked the height, we changed the height, right? We've changed it, we kind of reset it now to this number, and then kind of reset it here, okay? I want to be sure we can also reset our frame per second. Let's just know if we can actually do that. And then, yeah, we could maybe want to do that. And yeah, we could do that anyway, but let's kind of run that outside of this environment. Maybe set cap dot set, then we'll have CV2 cap prop FPS, right? And then we will set it at, maybe let's kind of reduce it 2 seconds per frame. Let's reduce it to like 10. So let's run this and see this. Okay, it's true, that works. That works, that works. So let's just kind of put that there. And I've changed it. It's true. It is true. So now that means it's definitely going to be very fast now. And then what next are we going to do? We're all going to be running all of this here. And then the next thing we're going to do now is let me just, that true, I need to set it at something, because what I said is camera opened, print, checked if camera is opened first. Yeah, okay. Okay, and well, let me just kind of put a, okay, so now the next thing we're going to do now is, since we've set the camera, and then we're gonna do because before we run into the while loop now, we want to be sure. So we're gonna say if so first of all we'll say uh ret comma frame is equals to cap dot read, okay? And then we'll say if ret print f string camera height, so it's camera new shape is going to be frame dot shape, and also print camera. What else would we need when we are reading it? Maybe we could read camera data type. We are going to be frame dot data type, or type of data frame. So let's see, it opens. And the camera data type is uint, which we agreed then. I'm just going to do cap dot release. All right, so okay, so that works. And so now you see here we kind of changed it to 720, 120, 1280, and then 3. That's the three-dimensional. So what if I had done something like maybe type of frame? Let's see what that's going to give us. Of course, it just give us an array. Yes, of course, it gives us a class of array. So, so that's just kind of the type, and okay, that works. Now, so that's actually going to be that. And the next thing we're going to do now is we are going to run into a while loop now, right? Because we're going to run into a while loop. So I'm going to say while true, then ret frame and capital read. I think we might want to put this in a new line, but for now, let's just kind of see what happens. Now, if not ret, as if it's not true. So it means, what this means is if it's not true, so it's going to print frame capture field, then break out of this loop. Okay, but then if it's continuous, so CV2, we might say else. It's still good practice for some of us who are learning. So say else CV2 dot I am sure, and then I'm just going to say, okay, here we're going to call it camera and frame, okay? And then the key is going to be equal to, now we're going to have something like a key, and then we're going to CV2 dot width key, just width key, and then of course we could keep it at 1. So now one of the things I want you to understand is that a width key at 1, it's kind of just maybe width key at 1 is maybe like 1 milliseconds. So this is kind of what that controls the speed of your camera for video loop. So this is just something that will control the speed of your video loop, okay? Then guys, then maybe it is kind of width key of that one, then that means kind of it's going to check every 33 milliseconds, right? Which is minus 33 frame per second. Whereas if it is a wait key for 0, and then that means it's going to wait forever, it's going to wait forever. If you kind of put that, that's maybe when the camera displays and the wait key is 0, it's going to wait forever. And then, so for anything like live camera that we are doing like this, I will always suggest you guys just kind of use the width key of 1. That really works very well. So if the key now is kind of equal to D and then Q, right? That's the number the person. So plus click. Then what you're going to do now is just kind of break out of that loop, and then of course once you break out, and do capital release. Okay. All right. So I think there's actually that. And then it releases whenever we want to kind of just get some stuff all done or whatever thing. So could just destroy all windows. Maybe just do some CV2 command, destroy all windows. So I'm gonna run that, and then that starts. That was very fast, guys. That was really very fast. frame capture failed automatically. And I think that's because we kind of changed this to 10. So maybe probably we'll just kind of uncomment this part. Okay, gonna run it. Frame capture still failed. And that's fine. I think okay, okay, yes. Yeah, the reason why it failed is because I'm currently doing a video streaming now, so I'm currently on Zoom right now. So I don't think I can be able to capture a frame while kind of displaying this. But the idea there is that for computer vision now, what you just want to kind of understand now is that this is kind of a while loop that's really going to help out. So read frame capture read. So it's kind of this is going to read once. So if not read, if it's not true, that's going to print capture failed. Okay, and then it's kind of broke out of that loop, right? But then else, cv2.im show is going to show one of the frame, and then the key is equals to this. So it's going to kind of wait, right? While it's true. And then if the person press Q, it's going to break out and then releases it. Now, the next one we're going to be looking at now is we're going to be looking at flipping and rotating, right? Flipping and rotating. Okay, how can flip and rotate images in computer vision? That's actually a very important part that we're going to be talking about, right? And not really very difficult, something quite very simple. Now think about data augmentation. And most times when you have an image, right, you might want to flip the image. Let's say, for example, you want to train a neural network now, and you have like, let's say, for example, you have 100 images available, right? And you don't have enough images, then probably what you might be doing for data augmentation is what we call flipping and what? Rotating. So you have to kind of turn those images at various parts. Some of them you might blur them, which we might talk about later, blurring. And then these things are actually very essential, in terms of how you more of, I'm just going to say, put it this way, how you manage images, right? Before you, it's just basically think about it like how you kind of get more access to more images, right? So the first thing, one of the very important methods there is cv2.flip, okay? cv2.flip. So that's one of the very most essential methods for flipping and rotation and all of that, right? So you could flip the image horizontally, you could flip it vertically, you could, like you could just turn it how you want. So let's create an image. We could use this image of this dog now. I think that one is going to really be very helpful for us. We don't want to really start searching for another image. The image of this dog is really going to be very helpful. And essentially, what we don't want to do right now is kind of, because we need to kind of read this image. So we'll say, first of all, dog image, I think it's still here. So let's kind of print. And actually, I'm going to do it again so that for those of us who might actually be coming at this point, dog image. Because if I kind of print, let me just print dog image and see what we're gonna see. A numpy array, three-dimensional numpy array, and because we're gonna do dog shape, dog image dot shape, dog image dot shape. Okay, it's gonna be a numpy array, that's fine. So I am going to say now, let me just kind of reassign that again so you guys can actually understand what I was doing. I'm going to say cv2.im read, and then I'm going to pass in, it's going to take in dog, just kind of the photo, that's new dog.jpg, and then it's going to be im read, then it's going to be at color. I think this is Um, I just want to be sure these dependencies are quite well installed. So, because gonna import CV to I am read. CV2 dot I am read RGB. Let's kind of plug that. Let me CV2 dot I am sure of dog image, and then CV2 dot width key. Let's see. Okay. Width key. Mm, Okay, I think what's stopping us from seeing this image could. Oh, look at the image here. It keeps displaying, but we are not seeing it. Oh my goodness. And that's it. So that is the image. Okay, let me just kind of minimize this a bit. And we just call it a dog, and then when we run that, it kind of shows us the image. Okay, our VS Code terminal, we're thinking it's going to pop up somewhere here and all of that. But then you see, it's kind of not showing us the right image. So we'll do dog image because we want to kind of flip this image. I want to turn it. So what would the dog image is equals to cv2 dot convert color, right? And then we're going to pass in dog image now. So this is going to be, we'll call it new dog image. So passing the dog image. I'm going to close this now. Let's kind of close that. So dog image, and we have dog image. So we'll do cv2 dot, so what we're going to pass it from now is going to be color RGB, no, this is from BGR. We call the RGB to BGR. We could say BGR to RGB. Let's even see what will happen. New doc image, right? So let's run that. What's this? What's all this? So that's it. So it kind of gives us the real doc. So it has to continue running until we close it up, right? But if we kind of change this width key to 1 and run it, wait, let's just close this one first. You see it's going to close. It's going to 1 second. And then I think there was kind of some crash there, when we were trying to do that. And just gonna wait for the program to respond. Try to restore the program. Okay, let's just kind of close it. Okay, so our kernel crashed because of that fast changes that I was kind of making. So I'm going to restart our kernel. Okay, so we're just going to restart it. And then once it restarts, then we're going to run our kernel, and that's it. So this is what we need to understand about OpenCV, right? Very, very important. Not really so technical, but quite very imperative for anybody who is kind of trying to navigate a path in OpenCV. So I'm just going to run this. We'll let everything run. I hope there is no image that we might encounter on the road that we didn't close. So it's just running. So one of these, I'm definitely going to show you guys how to build a machine learning library from scratch using C. So it's kind of running, and I think this should terminate now. Okay, it has left that cell, that's running, and I'm going to close this, and that's fine. So that's one, since it's about Python, very procedural, but it has multiple paradigms, though you could use classes, object, logic-based programming, all of that, kind of run the methods that you want. So that's one of the logics in programming. But I want to, okay, so what brought us here is that we wanted to just kind of load an image, right? And then we'll have the new dog image. So if we use plot dot I am show, and then we'll pass new dog image, it's going to give us the image. It's still giving us this image in this corner. What's wrong with what's okay, so we'll go up slightly, and I think we can, could just check. This is RGB. Let's just kind of remove this entirely. So yeah, so we don't need to have that method because that's kind of turning it to RGB, looking like it's doing the opposite. So we have our new dog image, right? And of course, we could just knock out the axis, right? So say dot axis off. Now, one of the things I want to tell you guys, so you kind of just look at this because these are flutes, right? One of what I need to explain to you right now is, okay, I think could just kind of just close this carefully. Now, if we want to kind of flip an image now, how do we flip it now? Now, the first thing we want to do now is we are definitely going to have that CV2 dot flip, and then of course we'll have the image, and then we'll have that's the flip code. What one of flip, that's the flip code. Okay, so this is usually how it's going to be. Now let's say we want to flip it horizontal now. So let's say dog horizontal. So this is going to be now going to assign that cv2 dot flip, and then we'll have a new dog image, and then of course we could just flip that by 1. That's to the right. So let's see. I am sure. Let's see how the dog looks like now. Dog horizontal. Let's just see. Okay, so we flipped it, right? So this is to the right. So that's kind of, we see we flipped it to the right. So 1, that's the argument here. So 1 is actually flipping it to the right. 1 flipped to the right. Okay, so now so now the idea is that when we are doing machine learning, right, and deep learning, we could want to uh flip our images uh in such a way that we can have more images that the machine is going to be trained on, or the neural network is going to be trained on. So that's what it is, right? So if we want to flip it vertically, let's say dog vertical is going to be cv2 dot flip. Sorry, excuse me. I'm going to say new dog image 0. So 0 is vertical, 1 is horizontal. So I'm just going to give you a markdown note for that. So let me just say 1 is equal to vertical flipping, and then 0 is equals to, okay, no, I think I'm trying to change it. This is horizontal flipping, and 1 is vertical flipping. Okay, plot the I'm show, and then passing dog vertical, dog vertical, and you see, turns it upside down. So that's plot dot axis force. So we don't have those axes there. So that's also what we do in neural networks, kind of turn these images. Okay. Now, let's say we want to kind of rotate it 90 degrees, like we want to rotate this picture, right? We want to rotate it kind of maybe 90 degrees, right? So what we're going to do now is we'll say rotate, dog rotate. So we'll say dog rotate, okay? Let me say dog rotate 90. It's going to be equal to cv2 dot rotate. And then, of course, I'm going to pass in the new dog image, and then now instead of writing 0, I'm now going to say cv2 dot rotate this image, rotate it 90, rotate it by 90 clockwise. Okay, let's see plot dot I'm sure. I think this image is kind of doing me somewhere in my eyes. Plot dot I'm sure. And then say dog rotate 90. Oh, I think let's plot dot axis off. I don't like seeing that axis off. So you see, that's it. Kind of rotate it in 90 degrees clockwise. So this is 90 degrees clockwise. Now let's say we want to rotate it by 180 degrees clockwise. That's upside down, right? So we're gonna say dog 180, 180 rotate is going to be equals to cv2 dot rotate. It's still going to take rotate method. Okay, so far we are rotating, right? So it can only take flip or rotate. Are you hearing me? It can only take flip or rotate. So now flipping now it can be 0 or 1, whereas rotate can be maybe rotate 90 degrees or rotate 180. And then counterclockwise also, which we're going to talk about in a jiffy now. So of course, rotate, and then what we're going to take passing is going to pass a new dog image. We're going to pass in the new dog image, and then of course we're going to say cv2 dot rotate 180. Okay, rotate 180. Okay, so that method exists. That's an argument. Then say plot dot I am sure, and then I'm going to press dog 180 rotate. It just turns it the other side. Okay, all right. You could want to remove the axis. I don't like that axis kind of off it. So the next one is going to be now we've rotated this dog, right? Now we could create our own images, but I think it's quite fine when we use some of these type of images because using these images kind of gives you some edge and more clarity. Now let's kind of rotate it. Let's rotate it to, let's say for example, we want to rotate it to um, maybe upside down, right? Oh no, this is actually upside down, right? Then let's say we want to rotate it by 90 degrees clockwise. So we're going to say rotate, say dog rotate uh, 90 clockwise is going to be equal to CV2 dot rotate, and then it's going to take in new dog image, and then CV2 dot rotate 90. That's going to be 90 counterclockwise, okay? Plot dot I am sure dog. I'm just going to kind of click this and then put another plot dot axis force. So you see, it kind of turns it again counterclockwise. So imagine you have like 200 skin lesions, images of maybe Burulai ulcer. In that case, you can just rotate it. Maybe you have those 200, you rotate and rotate and rotate, then blossom, and then it gives you much more images. And then there's also what we call WAPAFIN, which we're not really going to be saying so much about that. Because if you want to kind of get the center point of an image, it's still quite very possible for you to do. But we're not really going to go so much deep in that one. We're going to go straight into what we call blurring and filtering, okay? Blurring and filtering. Okay, all right. So that's the next thing we're going to do now, how to blur images and also perform filtering, all right? All right, now, so this is actually something that is very important. And so just like we talked about rotation now, when you want to train a neural network or when you want to perform some kind of deep learning project or whatever shit you're doing, there are tendencies that there are images that are quite blur, right? Now, if we're doing data augmentation, we want to get more images and all of that. We could do some sort of what? Blurring, then flipping. That way, it kind of gives us much more number of images that we want to use to train our data set. Right? So that's it. So now what we're going to be doing right now is there's some kind of methods that we have now. We say blood dog. When we want to blood this dog now, blood dog, right? Remember, this is new image, new dog image, right? That's what we're also working on. So I want to say this blood dog, gonna say CV2 dot Gaussian blur. We have the Gaussian blur, right? The Gaussian blur, and then I think that's it. Kind of takes in one argument, and just to be sure I can spell that correctly, and it's a new dog image, and then it's going to take in some numbers, so I'm going to explain shortly now. The one we call the kernel size, right? And this is kind of usually very negative. It's a 15 0. And 0 is usually what we call the sigmax. Okay, I'm just going to explain all of these parameters now. So we're going to run this to see if that works. Plot.imshow. Let's see what that looks like. Blood dog. Ooh, the dog is kind of blurred, right? It's no longer clear. Now look at this. And look at this. You see there are differences. So what we do is that when doing data augmentation, we also tend to give room for some images that might not really be clear, then kind of mix it up, then create more images and all of that, right? So that's actually for this dog now. And I'm going to kind of show you I'm going to explain what some of those arguments are, right? Let me just kind of copy this now, paste it here, and now, let me tell you something now. This is the constructor, right? No, no, this is not the constructor. This is the class, right? As a Gaussian blow that performs the action. And then that's why once you initialize once you import OpenCV, everything now starts from it's now dot method, you call this method and all of that. Now, but essentially what this thing now is talking about now is that it kind of gives us some insight on what I want to do now, right? Because uh now let me just explain the methods now, right? So Gaussian blur, normally the Gaussian blur is going to take in of course it's just going to be it's going to take in image as an image, then the kernel size, what we call the kernel size, which is this 15 here, and then it's going to take in the sigmax, which is 0, right? Now, let me now tell you what. Now, the kernel size, which is 15 here. Now, it's just the size of the blurring, right? This is the size of the blurring, right? And that's the blurring window or whatever thing you want to call it. That's okay. Let's see if we can let's just try to maybe reduce it to something like 5. Let's see what happens. You see that some part of it here is clear. Some parts here is clear, right? And then you see some of this part is clear. Because if you look at the previous dog here, it's almost similar, almost the same thing. Maybe just part of the image here is kind of clear. Let's kind of reduce it further to maybe 3 and 3. Or maybe we might not really notice much. Okay, what does it say? It says that, okay, the kernel size is kind of too small. Okay, no. We are having a mismatch. Excuse me. Okay, so now you see that what here, it's almost the same similar image, right? Let's just kind of reduce it to maybe 1 and see if that works. Nothing really. It didn't really blur anything. Now let's kind of increase it to maybe for example, maybe 25, 25, 25. No, it's not gonna work. Yeah, okay, maybe just kind of put it 25. It's very, very blur, right? And let's try to have an even number, 20, 20, and see what happens. It's not possible. You can't have an even number. It has to be what? A negative number. Now let's try it. It can work. But if we try 7 and 7, it works. So this actually works. We could just go on. You could feel free to try as much as possible. This code is definitely going to be available on my Git repository. But the most important thing you need to understand here now is what is happening beyond the hood. I think that is definitely going to be that, for blurring. And I kind of already told you what this is, and then I told you sigmax is this is kind of just kind of the standard deviation in the x direction. So you're saying something like deviation in the x direction, okay? And just that it's usually 0, just usually 0. Just try to leave it as 0, usually 0. Now, 0 means that OpenCV calculates it automatically. That's what it means actually. So most cases just pass zero for you to calculate that, unless maybe you have intentions of doing that. Now let's look at motion blur and maybe some kind of medium blur, you know, and then we probably could say dog medium, or maybe I'm just gonna start that with medium blur. Medium dog blur. Because CV2 dot median. Now this time around now we're gonna use CV2 dot median blur, right? And then we're passing new dog image. And then of course it's gonna take in maybe param of 5. No, because we could ask some questions why you didn't take that kernel, but that 5 is still the kernel. So it's not like a tuple that we used previously for the Gaussian blur. So that is just what it's going to be. And then let's see what is going that implies block dot I am sure. And then we're passing median dot blur. Of course, that works because we're going to explain the arguments now. Because if you look at this here now, right? I'm just going to kind of copy this. If you look at this here now, the median blur is going to take in it's going to take in as usual, it's going to take in the image and then the kernel score, which the kernel size, the kernel size. And I just want to know that the kernel size is usually an odd integer, right? So you can, and it's not a tuple, right? You don't have to pass a tuple there because let me show you what I mean by that. If you just try to pass a tuple here, maybe like maybe 5 is going to drop an error, expect an error, and that's it. So you can pass 7, right? You can pass 7, it's going to work. But you can't pass 6. 6 is a median number, okay? All right. So that is definitely going to be that. There are other things we could do as well. Once we do our median blur, it gives us some other insight. We can change the color and then do some kind of canny edges detection, which of course filters. We can kind of check edges because each of the pixel kind of becomes the average of the neighborhood. And yeah, but you might ask me actually whether we have a sample blur. I'm just going to show you we kind of have a sample blur. Say sample, maybe for example, dog blur. Dog blur is going to be cv2.blur. And then we have a new dog image, and then I think it's going to take in a tuple. It's going to take in a tuple, 10, 10, and that's going to work. Okay, so this is just a simple blur, just kind of an averaging blurs, right? So also have maybe cv2 dot maybe we want to check for edges. We'll do some kind of canny because this edges is called cv2 dot canny. I'm definitely going to show you that. But let's look at plot dot I am sure. And then we'll pass in simple dog blur. And then so it's going to give us, of course, still does give us that as well. Now, also for checking on edges, right? And then we could see, for example, this, we are still working with this. Maybe you want to ascertain the edges, maybe using a grayscale. So what I'm going to say is dog gray, right, is going to be equals to CV2 dot convert color. And then I'm going to pass in new doc image cv2 dot color. Then I'm going to say arrow bgr to gray, right? Now, what we could do now is this. We could see that the edges now is going to be equal to, now I'm going to cv2.canny, right? And that canny is a method that we use. And then I'm going to pass in dark gray. And of course, it could take in 100, 200, or whatever parameter that you want. So that's kind of the threshold and all of that. So we're going to run that. It has no attributes. Can this? Okay, so sorry, that actually didn't spell that correctly. So we must actually use grayscale image as input whenever we want to check the edges, right? So just make sure that you use a grayscale as the input for the place, okay? So that's actually going to be that. Because what you might actually ask me some of these two parameters here is because we kind of must convert it to check the edges now, right? So it means that this param here is for these edges, right? It's just kind of cv2.canny, right? And then this is the image must be in gray. And then this one now is the threshold one. No, let me not use this. So it doesn't look like we use a tuple. Threshold 1 and threshold 2. Okay? So quite important for you to know and have that in mind. So the threshold 1 is just kind of the edges, maybe that's kind of weaker. Then the edges that are weaker than that part is discarded. And of course, maybe, for example, threshold 2 is just kind of those upper edges. Think about it like those upper edges, and those ones that are stronger kind of get. So the edges between these two thresholds are only kept if connected to strong edges. So that's what you need to know. So the result is just a binary image, white pixels, and all of that. Let me just try to plot dots. I am sure edges and see. All right, so this is what we're talking about. So these are kind of the stronger edges, right? Particularly from that image. So just like I said, I'm going to say threshold 1 is just kind of the lower threshold edges, right? So edges that are lower than this, that means, we have the BGR numbers, right? So just think about it this way. Okay, now it has to be converted to grayscale, right? So it means that threshold 1 now is like those numbers that are less than 100 will be removed, right? So threshold 2 is just kind of the upper edges, right? So any kind of the upper edges, right, are kept. So exactly. So any kind of edge that's actually between that 100 and 200 is actually kept. So because you know that the range is usually 0 to 255. So these are some of the starting values that we usually use anytime we're trying to get edges. Remember, this is filtering and edges. Filtering. So one of the things I'm going to do now is I'm just going to kind of do the last thing I'm going to perform here now is that we can just align all of this now into a project. We could just have a project. Let's just have a project. and then a project that we could solve. And I'm just going to kind of delete this. Of course, the first thing I'm going to do, usually let's assume that we want to work on a real full-time project now. And then, which is kind of an annotated camera, right? So I'm just going to call this, okay, so I don't know why that went off. Annotated camera. So I've kind of used markdowns here so that you guys are really going to understand what I'm doing. So first of all, usually we import your dependencies, import CV2, import numpy as MP. And this time around, I'm going to be creating my own image. I'm going to say cap is equals to cap is equals to CV2 dot video capture. And then it's going to take in 0. And then if cap is open, if not cap dot is opened, right? Okay. Now we're gonna see how we're gonna print camera cannot be opened. Or maybe you could see something like maybe cannot open camera. Let us say cannot open the camera, right? And then I think there's a function that we could use here. We'll say exit. And that's fine. So here we'll say frame count is equals to 0. And then of course we're going to say while true this time. We're going to say ret frame is equals to cap.read. And then if not ret, so if not ret, so kind of break, okay? And then the next I'm going to say here is, I'm of course going to say else frame. I just want you guys to understand that because I could still just run frame count with that. That's still going to work. So I'm going to say frame count plus equals to 1. Okay, that's going to be fine. And then I'm going to tell you, so more like that, just kind of to get the dimensions of those frames, just like we did. And what we could do now is we could print a string of dimension of frame is, I'm going to say frame dot shape 0 and frame dot shape 1. Alternatively, I could say something like HW, right, is equals to frame dot shape of, because H is going to be 1, and frame dot shape of 0, right? That works. So we could just make a copy. We could say display is equals to maybe frame dot copy, and then also going to do a lot of things now inside of this particular frame, and then we'll now see. Now let's kind of draw a black bar on this frame now, right? Now, but the issue now is Most we don't really we might need to have a frame opened, right? And be sure that our camera is going to capture some of this so that while we are turning our eyes on it, it's kind of giving us what we want. So what we're going to do now is let us draw like some kind of a black bar. I'm just gonna, I think we could just expand this now because we've been coding here. So I'm just going to draw a black bar, uh, kind of at the top. Let me just draw it at the top. So what I'm going to do is I'm going to say CV2 dot uh, rectangle, and then of course it's going to take in frame, which is the first thing, and then maybe probably 60, 90, and 200, and then another one 200, 400, and another thing is going to take in outside after drawing that. It's going to take in the line size of 3. And I think that is just what it's going to take in. And of course, maybe the color channel. What's the color? It's going to be 255. Okay, if it's a black RGB, so that's going to be 0, 0, 0, and then of course 3. But if we want to fill it up entirely with a black something, so we could just do -1. That's going to fill everything up. So I'm going to write frame count CV2 dot put text. Okay. Now how we're going to do that? The first thing we're going to pass in now usually is the image, which is the frame. Oh, okay, this is going to be display. Oh, sorry, because we already changed it to display. So we're just going to change it to display. So we're going to see display, and I'm going to write I love programming, and of course it's going to be at maybe at 100 and 165, and we're going to have CV2 dot font and Hershey complex, and that's going to be 1.5 as that, and then the color is going to be maybe 0, it has to be 255, maybe 0, 255, 255, and then with the width of maybe 3. I think that's going to be that. And then you see v2 dot line AA, okay? And then okay, one can draw a central crosshair, or maybe I could just say, let me draw a central crosshair, cross line, or something. Maybe I could see 2 dot line. I'm going to say display, and then of course that width that I did put there now, I'm going to do this. I'm just going to take 2 and then -20, And because usually it has to take in like 4 arguments, right? So it has taken like two numbers. And okay, that's for line. So line is going to be 2. Yeah, of course, there's 1, 2, 1, 2. And I'm just kind of thinking now. So that's the first one. So it's going to be the height divided by 2. That works. And then it's going to take in the width divided by 2 plus the height divided by 2. And this is actually what it's going to take in. Okay. And then the next thing there is going to be the color, because it's going to be, there's what color we're going to paint this. I'm just thinking about the color 0255, 255, then 0. And then of course it's going to take in 2, which is that. I'm just going to kind of copy this, blind or display, but this time around, it's going to be minus some kind of, I think it's kind of better we just write it ourselves, display, and then it's going to be width of 2, h of 2, and 20, and then w of 2, and then of course I could just put just put h of 2 plus 20. Okay. And then of course, what color? I'm thinking 0, 2, 5, 5, and 0. And then of course it's going to be 2. All right, so that's going to show the grayscale in the corner using RI. And so what we could do now is we could just add maybe kind of a grayscale and then say CV2 dot convert color, right? And then we have our frame, and of course go CV2 dot color. That's RGB to gray. So gray small is going to be equal CV2 dot the size. I don't have gray. I don't have 100, maybe 160, 120, right? So gray large, of course, maybe we'll say gray BGR. Okay, for more probably want to the kind of thing, BGR is going to make us CV2 dot convert color. Convert color. Now we're kind of taking it back to gray small. And then CV2 dot color gray to BGR. Okay. Okay, all right. So we actually converted that. We actually converted it. So we can paste it into column. Right. Okay. That's one reason why we did that. And then display here is going to be our 55 up until 175, and then 0 up until 160, right? So it's going to be equals to that gray BGR. Okay, so that's kind of what we're doing here. That we're kind of pasting it, paste it at the top left area below the black bar. Okay, with the black bar. All right. So actually, what we're gonna let us show the edges. Let me now show you guys the edges of that's the edges version in another corner of your camera. Okay, yeah. So edges is equals to cv2.cani. Now I'm going to get that gray, and then I'm going to do it based on maybe it's going to be 60 and 160. Now remember that I kind of assigned gray here, so just so you know what I kind of did, right? Because we must, to show the edges, it must be in gray. Now think about it. There are some cameras that you kind of open. When you open the camera, you will see some edges, right? All right, so guys, the next thing we're gonna do now is once we kind of have that insight, right? And then the next thing we're going to do now is we're gonna say edges small, and then it's gonna be CV2 dot resize edges 100, 120. Okay, edges PGR is going to be CV2 dot convert color, right? And then it's going to be edges small, and then CV2 dot color gray to BG. Okay, so now the next thing we're going to do now is so we're kind of going to run a display now, and then we're going to say maybe 55 of 175, and then of course we could do maybe W minus, so this is going to be our width minus 160, right? Minus 160 in our what? W. So that's going to be that. That's the edges. It's going to be equals. So of course, we're going to actually assign this now. So it's going to go edges BGR CV2 dot I am sure OpenCV grind. Okay, let's call it grind, and then display the key is equals to CV2 dot width key 1. Okay, and then if key break, and then if key final is going to be equals to f of capture frame count dot jpg, right? And then of course we're going to say cv2 dot im right, and then we're going to call it what we're going to call this thing now. I'm going to pass in file name and then the frame. So print f saved file name successful. If key, if the key is equals to ORD f frame is going to now be equals to cv2 dot flip, and it's going to be frame 1. This is just to press F to flip the frame horizontal. Cap the release C2, but destroy. We're running no module name numpy. So go up. NumPy. Now let it run. It kind of opens. And that's it. Kind of wondering if we showed an image. So maybe we could just put something here. If I thought it broke, because of all the long code that we're writing here, we could just say if not read, break, because we don't want to have spaghetti code. We're gonna print by. Run it again. Okay, it said frame is not defined. I want to know. Oh, sorry, kind of jumped up. Frame is not defined. Oh, frame. This is frame. And so could not broadcast array. UGL, so gonna check where it was a mistake we made. What we're going to do now is we are going to just from the shape, let's just kind of good dimension is 40, could not broadcast array, and all of that. And we could just comment that out. Okay, so you can actually see that my camera is showing, and so that's it. So yes, everything is actually working. The frame is this, and if I press F, so I kind of pressed F Q. All right, so that's that, and so that's actually going to be that for this video. If you found this video very helpful, okay, I'm just gonna stop that while loop. Okay, so you could see that that project was really a very magnificent one. And of course, we could run that again. And that is that. So I'm just going to kind of comment this one back. So that's all right. So that is going to be that. We could close that. And yes, that's going to be that. Kernel base is dead. But then I think actually this video made a lot of sense to you. And if you kind of found this video very helpful, that's really, we've kind of covered a lot of things you need to know, particularly with getting started with OpenCV. And I'm going to be sharing this code base on my Git repository for you, anybody who's actually going to really be very interested in getting started with OpenCV. So this is everything you need to know about OpenCV, at least to get started from foundational level. Other than that, uh, I'm going to say a very big thank you for your time, and see you on the next one. Bye-bye.